Very good afternoon, everyone, and a very warm welcome to the webinar, which is titled IT Infrastructure for Geospatial 2.0. As you all know, the year 2021 has been a blessing for the geospatial industry, with two very positive policies being introduced. One on the geospatial data and guidelines, which is at the last stages of being finalized, and the other one on drone rules. Both these policies have added a burst of life to our industry, opening tremendous opportunities for the geospatial data capture, creation, processing, and sharing businesses. The government departments as well are appreciative of the move since the new policy will allow a lot of the pending geospatial data capture and processing work to be expedited. In this scenario, organizations, both government and private, are looking to build their geospatial infrastructure, which includes the right computer hardware, software, storage, networking gear, etc. However, considering the variety of choices available today, choosing the right technology is not an easy decision to make. Many users are looking to build cooperation with core IT companies, CSPs, SIs, for establishment of fully managed cloud services infrastructure based on infra as a service, platform as a service, and software as a service for all processing and data production activities, including storage, using fast and secure connectivity. We are also looking for developing robust data management solutions to help our users understand IT infrastructure prerequisites and providing an understanding of the best suited infrastructure for hosting, processing, storing, and sharing GIS-based data. AGI is conducting today's webinar. We have with us an impressive lineup of senior speakers from some of the leading IT companies who would be sharing their experiences and insights on technology trends related to server, storage, cloud computing, GPU computing, and database management. Each talk will be equally valuable as it adds to our perspective, and we hope to make this an engaging webinar. So if you have any questions for the speakers, feel free to send them to us over the chat box. So now, not taking any more time, I would like to invite Mr. Agendra Kumar, President of AGI, to deliver his welcome address. Over to you, Agendra.
Thank you, Megha. Thank you for the nice overview of today's webinar. As Megha mentioned, a couple of policy changes which happened this year have made a phenomenal difference to the geospatial sector. As you would know, geospatial technologies are important both in government as well as private sector, and there was a lot of ambiguity and challenges till the new policies came in. So the first change we had this year was earlier in the year, in month of February, when government announced new geospatial data guidelines. And this was a remarkable change that we had from multiple policies which were released over a period of two and a half decades. And there was no clarity which one of them should be followed and which one should not be. Government has come out with one comprehensive and simple geospatial data guideline, which is available to every user in the country, and they've simplified the whole method of collecting geospatial data, processing it, managing it, and distributing it, sharing with each other. There's a lot of simplicity which has come, and the best thing is that the basic premise for this policy change was that if there are two important things. One is that if any data is available easily outside the country, then it should also be made available to users inside the country. And second big change was that if data has been created by a government organization using public money, then it should be shared easily with other users in the country, both in private as well as government sector, and to the extent possible free of charge. But if data is the collection of data has cost a lot of money, then there should be a reasonable charge for that data. So these kind of the philosophical change is very important, from control to enablement. And the second big change that we have seen recently is about new drone rules 2021, which have been announced by Ministry of Civil Aviation. The drones and geospatial are quite close to each other, and usage of drones for data collection and data collection for a variety of applications will go a long way in supporting government applications and applications in private sector. And many of these applications were not possible because the flying drone was very cumbersome. It needed as many as 25 permissions, and which has come down to 5 now. And there was lack of clarity where one can fly, where one cannot fly. And there's clarity coming in that as well very soon. And also, as I mentioned, the geospatial policy framework was not very clear. Now, all the demand forecasting, demand projections that were done earlier, those were done keeping in mind the older policies. Now, definitely these new policies will help in growing the demand a lot. There'll be many new government projects, many new applications in private sector which are going to come, and the demand will certainly be much higher than what was projected in our plans last year. Some of the government's important schemes are like the Swamitva scheme of Panchayati Raj, which is being executed by Survey of India. They are the partners with Ministry of Panchayati Raj for this project. And here the survey of 650,000 villages, 6.5 lakh villages is to be done, and through drones. So there'll be a lot of data creation. There'll be a lot of usage of that data for providing the land title to the farmers, which will make a huge impact on the economy of the country, because these farmers will be able to use that land as a collateral if they need for a loan from the bank, instead of going to a private lender who charges very high interest. Sometimes it's as high as 3 or 4% a month. So instead of that, a farmer will be able to borrow money at a much lower rate from a bank. Then there are a lot of infrastructure development projects which are happening in the country. These are in areas like roads and highways, airports, many other projects in port-related projects. So there are a lot of work which is happening where drones and geospatial technologies can be used for a variety of decision making and monitoring of projects, and in general mapping, so that land acquisition, land management, all those things can become much easier. Some of the other areas are utilities, agriculture, water resources, town and country planning applications, municipal applications. So there are many areas where there'll be new applications coming in. And as new data becomes available, whether it's through drones or satellite imagery or LiDAR surveys or any other way of collection, in any GIS application, geospatial data plays a very important role. And often this data is very large to process, large to store, and with the as per the new guidelines, sharing of data will become easier from one department to the other department. So there'll be need to set up geo portals. In fact, the draft policy that government released also talks about setting up of geo portals, so that the geospatial data can be easily shared among different users. Now, when we do this sharing, then a infrastructure is required. The geospatial infrastructure is required, which is a combination of hardware, software, network bandwidth, different application software, data. So all those things have to be brought together to make sure that this data which is collected, it's available to a larger user base across the country. And when that data is to be shared and processed and stored, today users they see different options. They see options of traditional ways of creating infrastructure on premise, where they have everything in their own offices, and they bring all the data, they process it there, and they store it there, and from there they share or disseminate for use by other users. Some of them are considering cloud-based geoportals or infrastructure creation, so that their investment comes down, and instead of capital expenses, they are able to use as a revenue expense, and they can they can pay for what they consume and not really invest everything upfront. So that's another model which is being looked at in many organizations, both in government as well as in private sector. And then because Ministry of IT and Ministry of Electronics and IT has approved a lot of private sector clouds, so the flexibility of using a cloud is larger, apart from some clouds which are being offered by government or public sector organizations. There are several private sector clouds also available which give a larger choice to government organizations. Then there are different kind of hybrid models, have something on premise and have something in the cloud. There are co-location models. So there are a whole lot of different choices which are available today, which provide options to customers to manage their IT infrastructure in a way which is more appropriate for their budgets, processes, and requirements. So we felt that, and I'm sure each of these have their own pros and cons, and then in some cases they will be more cost effective, but there may be some technological changes which one has to make. In some cases, a hybrid model may work better. So looking at these kind of challenges, we at AGI felt that it's an appropriate time that we bring various players from the IT industry who can share their perspective on the infrastructure which should be created for geospatial applications. And this infrastructure is required. If you look at the government organization, this infrastructure will be required at sometime at district level, state level, and national level, so that the data which is generated in districts can be brought together at a state level for usage, especially data which pertains to agriculture or city or municipal applications. So those or health related applications can be brought into at the state level, and then it can be made available at the country level for different ministries to make decisions which have impact all over the country. So how should this be managed is a key question, and there are, as I mentioned, there could be multiple ways of doing it. And some of the experts which are available today from different companies, and these companies specialize in storage or cloud or hardware or software. So these are some of the components of IT infrastructure which are important. So the idea was to invite some customers so that they can share the perspective that they have about building a geospatial infrastructure and how it should be created and managed, and what are the benefits of one versus the other. So I hope that we'll be able to get some insights into these challenges of selecting one way of building infrastructure versus the other, which is in the minds of many of geospatial users in the country. And hopefully we'll be able to get some clarity, get some better understanding of doing it one way or the other. And if we are able to achieve that, I would say that this webinar would meet its purpose. So I think that's what I wanted to share in this short introduction. And Megha, over to you to invite the first speaker for the day.
Thank you so much, Agendra, for giving that overview. I would now like to invite the first speaker, who's Mr. Ranganath Sadasiva. He's a Chief Technology Officer, Hybrid IT at Hewlett Packard Enterprise, India. Ranganath is responsible for bringing in thought leadership across HPE hybrid IT business and delivering best-in-class technology experience for customers. He works closely with the enterprise segments, understanding their business and technical needs, developing HPE's point of view aligned to HPE technology vision. With more than 26 years of experience in technology industry, Ranganath is an accomplished technologist and management executive across core ICT technologies, working predominantly in India, Asia Pacific, and Japan region. He has done various customer-centric roles across sales, product development, and consulting in these geographies. Before joining HPE, Ranganath served as a director, enterprise research for IDC India, and was responsible for overall enterprise research in areas including hardware server, storage, networking, enterprise software, enterprise services, and emerging technologies like cloud, IoT, AI, big data, etc. Widely known in the industry For his insights on technology and its articulation, he is a regular speaker at customer industry forums. He is also a mentor of change with Niti Aayog, Government of India. Ranganath has a Master's of Business Administration degree in marketing from Bangalore University and a Bachelor of Engineering degree in Electrical Engineering from BMS College of Engineering in Bangalore. He would be speaking on computing for the new geospatial world. Over to you, Mr. Ranganath.
Thanks, Megha. Absolute pleasure to be taking part in this particular event. You should trust me when I say that geospatial has really caught my attention in the last 6 months, and thanks to all social media and stuff like that, it's really a technology that I started to focus on and kind of gained a lot of interest. And as if to say the world conspires to help you, I'm here speaking in a forum which is essentially speaking about geospatial technologies. Let me share my screen here. Yeah, you should be hopefully seeing my screen, Megha.
Yes, yes, we can see that.
Okay. So I'm going to focus on the compute aspects in a geospatial world, and as Agendra nicely put, there is an explosion that's happening here from a geospatial technology perspective, coming in from technology itself, coming in from the way data is being released by governmental and nodal agencies here today. So I see a gambit of possibilities, a few of which was essentially touched upon by Agendra. But purely in the context of what we really see in the marketplace, if we were to take the entire market landscape today, there is a buzzword which we talk about, transformation. So digital transformation is essentially digitizing a lot of your product services and solutions. And in that context, I would say digital transformation holds good for the geospatial world as well. Given the fact that there has been so many changes that are happening and is bound to happen as we move on. So in that world, we are looking at many possibilities, and the possibilities is led by a lot of technology adoption. First of all, if you look at the way we kind of look at these transformations, that leads to kind of various possibilities within your organizations, right? From a digital perspective, you're talking of many digital product and solutions coming into the play. But if you're also looking at what you get out of it, is a lot of agility within the resources that is there, whether it is the usage of these assets or data that you have, whether you're building more efficiencies around it, and perhaps looking at greater innovations, right? I see this as the creation of a platform, and that is where when you're looking at these platforms, getting the right compute resourcing becomes very important, right? So that is where I would want to kind of tell you about how we kind of optimize these compute resources so that it meets the objectives of an industry like yours. And all of this in the new world today means that you need the cloud dynamics. So can this all be delivered in an as a service experience? That is again what we are focusing on as HPE. So if I look at these needs, I see a kind of triangulation of activities that happen. First is in terms of how you would want to collect data, right? That is something that you have been doing, and there are various other technologies where the input for these kind of resources is happening. Next is a very important aspect where you try and analyze the data for various use cases that was spelled out earlier, or various use cases that we will see further ahead. So for that analysis, what is the backbone of that is essentially going to be the compute power that you're going to have, right? The software stack that you're going to develop around it, the agility to kind of harness the data, that becomes very important. So while you compute, there is an equal importance to the way you store data, which is just the first attribute. But more importantly, how would you add intelligence to that, that data? How would you gain knowledge about the data? How would you gain wisdom about the knowledge? So that is how the entire hierarchy of things would essentially move. But what is important to note is all of this is now under a time wrap, right? How quickly can I do that? That brings a lot of focus in terms of what is the compute resource you have, how do you use these compute resources, because you're now time shrunk, right? You want to do that as quickly as possible, almost real time, as we see in many situations. So if I take an example of earth sciences and look at what are the core drivers, right? Where you're having what I say, the collection of data that is happening through various sources that is there. Then you're also understanding data that you previously collected. You're also kind of looking at analysis across this, across various dimensions, right? In such a situation, I see three core drivers really emerge. One is the performance of the compute resource that becomes very important. How quickly can you yield those results? How quickly can you get those results? So you need to have something that is going to perform to today and something that can perform beyond as well. That becomes a core driver. The next is about the reliability of your compute resource. This extends to the data center or it extends to any other IT infrastructure geography that you might have, right? How do you ensure that there is that reliability across your devices? Because these are complex projects, complex data being analyzed, take some time to do all of that. You cannot have unreliability issues really crop in. And last but not the least is the kind of analysis that you have. It is how you look at data that really matters. It was always there. The perspectives have to change, and those perspectives are enabled today with a lot of technology aspects that come into play, right? So this I see as core drivers. And if I look at scalability and what's happening to the industry per se, the need for scalability is definitely coming in from an application perspective, right? The application needs more compute power, perhaps need more computers, more cores and stuff like that. But there has been this Dennard scaling, which essentially ended 15 years ago, which limits your capability to kind of scale within a given footprint. So you will have to look at how do you increase your cores or processors, between any given time. And the next aspect is about algorithms that you have in terms of how you look at managing each problem, right? And those are also growing pretty much in size and shape. So we need to have more compute power, more capability on the software front, more capability on the storage front to redo that. And the kind of analysis that we are doing, or the computational analysis that we are doing today, are only growing in terms of its complexities, right? The kind of requirements that is coming out of, say, quasi-uniform grids, or if you're looking at, the pole problems and stuff like that, where you need extensive scalability. So that is really coming out as one of the definitive points that you need to consider when you're looking at compute capabilities. The other thing is compute itself and the way you look at computing, right? There is a lot of diversity that has come through in terms of the processing ability within our domain today. Gone are the days where we just had CPUs to do everything, and we were throwing CPUs for any given problem, irrespective of the nature of the problem. So there was this architectural specialization that came about, and today we are talking of CPUs, we are talking of vector processors, we are talking of GPUs, we're talking of AI chips, and added to that, the ability to kind of process many things in memory is also growing. So you have a lot of technology that allows you to have memory available, whether it is onboarded or whether it is coming out of storage class memory. So the entire ecosystem within the compute domain is also transforming to enable the geospatial world. Let's look at the other things which are beyond the hardware here, which is also requiring or asking more power and juice within the workloads that we see. We are talking of multiple software stacks today which are used for analysis. We are seeing that the applications are getting containerized. We are seeing new AI frameworks really come into play. A lot of them that are adding to the cost for you to look at compute very seriously and have your set of considerations really kind of map onto the requirements that is there. In a nutshell, if you're looking at modeling and simulation, I think that is really changing dramatically. Each day you're seeing various models. The simulations are getting heavier and heavier. Then there is this aspect of looking at artificial intelligence. We are asking the questions, what if, what when, what how? So those kind of questions are coming in, which are all have to be answered by artificial intelligence and with the capabilities of the big data and analytics that are there. And today, as we speak, we are talking of compute, which requirements which are exascale. We are entering into the exascale is what we say. Exascale is 10 to the power of 18 operations per second. That's the kind of scale that we're looking at, and we are delivering systems, and organizations are using these kind of systems. So very important to kind of have a look at all of this when you're considering your own capabilities. If I were to kind of put all of that together, any enterprise today, 8 questions, as a quick summary for you. I spoke about workloads, because every workload has its fingerprint. How do you essentially use that workload becomes very important. And if you're looking at intelligence from your data, how do you do those analytics, right? And how quickly you want it on a scale of time, that is becoming important. You cannot look for performance delays, right? If you're doing a bank transaction today, or if you're looking at a satellite run, you want to have that as quickly as possible. So performance becomes very, very crucial. Are you able to shrink time again and save time? That becomes important. If you're looking at understanding your data and creating models so that you can get greater insights, are these models being, can you deliver these models as quickly as possible? Yes, software can, but can also hardware be hand in hand alongside that? That is what is something that's emerging out of AI ML pipeline creations today. And the amount of data, what is the kind of data that you need to analyze, also becoming very important. You're going to create much more data, and it's me and you who are creating this data. But again, how do you get more out of the data becomes an important aspect and attribute to look at. I don't know how much of remote work has impacted, but generally across the board, there has been this 360-degree change in terms of how do you ensure that the resources that are lying there in one prescribed place is available as a remote, for remote logins and for remote work. And obviously, the budgets are all shrinking, technology is changing, so you need to kind of really look at how can you optimize on that. And last but not the least is the security aspect. How secure is our infrastructure? And especially given the kind of policy enhancements that we are seeing, the liberalization of the policy, the maturity of using geospatial technology, which is also scaling today, ensures that we need to kind of take this data to many more agencies apart from the stipulated ones. So security becomes important. So, in the context of all of that, if you look at HP and its capability, we essentially cater to 4 pillars, which becomes very important, which will allow you to transform the way you compute, right? Whether it is the workloads that we are looking at, because workload characteristics are changing dramatically, or is it the ability to deliver to a 360-degree security policy, right? How do you fundamentally build infrastructure for this policy? That is an important aspect. How do you build automation to a lot of mundane tasks that you do, right? Your IT infrastructure can be automized to a great extent if you have intelligence in that. And that is something that we're focused on. And last but not the least is, given the dynamics of how you can procure your infrastructure today, gone are the days where you just wanted to keep it in your premises. You might want to keep it in your premises. You might want to keep it in the cloud. You might want to host it somewhere. Can I have that hybrid experience? Can I get that cloud-like experience? That is where, the focus is on delivering everything as a service from HP's perspective. Quickly on workload optimization, what does it deliver? What do I mean when I say workload optimization? It basically looks at the characteristics of the workload and creates a fingerprint for it. And based on the experience that we have, we are able to ensure that the compute resourcing is optimum for that particular workload. So what does it ensure? It ensures that there is no guesswork in the way we do things. It ensures optimizing of time. It ensures that you have more time to really focus on a lot of agility around compute. Some standing testimony around this is the way we kind of use these capabilities and in various situations today, right? The tools that go along with the compute aspects allows you to provision and get your entire compute resources up and running almost 5x faster. The automation ensures that you have lesser than, eliminates many things and ensures that the number of steps that you have to do that becomes reduces. Likewise, if you're looking at certain things around applications, whether it is Citrix logins or SAP, the entire complexity is what we are able to reduce, and also ensuring that you are on track every time, because there are validations that are pretty much relevant, coming out of the experience that we have had with doing such kind of things across the globe, right? So this is what workload optimization really delivers to you. Next is this aspect of security. No conversation really stops without talking about security, right? And how do I help building an zero trust architecture and building security that is foolproof is our ability to ensure that security, which is now kind of permeating deep down into a data center, right? It is getting into chips and it is getting into processors, it is getting into firmware. So that is where HP has this technology called Silicon Root of Trust, where we are able to essentially stem out any kind of malware and
So,
ransomware that is coming our way.
so
Right?
currently also, I'm only seeing the speaker on both the screen.
Hello? Hello, was there a
Yes.
question?
No. Please continue.
Okay, you're able to see my screen, right?
Yes.
Okay. So I was talking to you about the ability to ward off any such kind of security threats that can come in. And obviously, security is a very layered exercise. You'll have to guard everything that is exposed to the external world. But what I'm delivering to you is a rock solid base, an infrastructure base in which you can build your entire security framework on a zero trust architecture. You might go and do that for your network, you might do it for your applications, you might do it for your endpoints. Essentially, all of that can be done. And we go to the extent of looking at trusted supply chain as well. Where are the components coming from? Can I trace that? Where is it manufactured? Can it be done uniquely for a given customer? If he has security issues. So all of this is possible from a security framework, and we are looking at a 360-degree security, that can be formulated for a given customer. And last but not the least is the intelligent automation that is needed to handle your resources, right? Whether it is for server management, whether it is infrastructure management, to going into managing several other things that are part of the infrastructure. There is HP OneView that delivers that. HP integrated lights out does the capability of server management, and HP InfoSight, which is very uniquely developed as an AI tool to ensure that the operations that you have within the server, whether it is monitoring the parameters there, whether it is giving you useful recommendations based on the observations that we have had, everything that automizes your entire server infrastructure is what we do. That is InfoSight that delivers intelligent automation. Um, so if you look at the requirements of compute today, it can vary depending on various scenarios, right? Whether you want to deliver that in the edge, whether you want to put that in a data center, whether you want high performance computing, whether you want normal computing, whether you want a different form factor to do that. So the entire portfolio of compute is what is available today from an HPE stack, right from rack mount servers till the highest end exascale that I spoke of, where we can deliver the entire spectrum of compute capabilities in various form factors, depending on where you would want to put that, on the edge or on the cloud or in a hosted environment, along with a lot of storage capability that there is a focus around that, but not speaking much, but which delivers in conjunction with the compute storage and compute data leading towards insights, right? Some of them are very specifically designed to ensure that a lot of capabilities around geospatial environments, especially pairing up with GPUs. And that happens across the portfolio for us, where we are able to actually deliver the various other accelerating parameters like a GPU or a FPGA card or anything like that, that essentially augments your compute capability when you're trying to do your geospatial applications. These also kind of conform to a lot of geospatial tools and applications that are there, and that goes hand in hand to ensure that when you're looking at compute capability, you're essentially getting the best of both all worlds. And wherever you would want compute, there is a compute device available. In fact, we've gone to the extent of taking some compute devices to space. We have a space program that we work with NASA, and it took off, carrying some of the latest compute on space into the space and doing a lot of activity there, right from the edge there in space to something that is geo, that's on Earth. You're able to kind of deliver a lot of compute capability to you. My last slide, which essentially speaks about why should you look at HP. Some of the parameters that I really spoke of in terms of performance, there is an entire scale of performance that allows you, that is allowed within the compute framework, and we can match any kind of performance needs that you have, scaling from the absolute minimum to the absolute maximum, right? And we're talking of reliability. One is, we have been in this industry for so many years, 80 plus years, and we have been doing this work for a period of time. So there is a sense of reliability from an organizational standpoint. There is a sense of reliability from the product perspective as well. The Proliant brand is almost a gold standard that way. Next is the spectrum, as I said, right? Whichever be the use that you have, whether you want to put that into a car, whether you want to take that into a satellite, whether you want it in a data center or on the cloud, we have this entire spectrum of computing capability that is available. We essentially believe in enabling a lot of the compute capabilities for now and for the future as well. And that is where you see a lot of innovation coming from our side in terms of augmenting capability across the board, right? And the experience that we have, we run a lot of these installations within the country, outside the country as well, and have understood the dynamics of this particular industry in a very big way, leading up to being providing the largest exascale systems in the world, to some lot of data that we analyze here. uh, with that, I would want to thank each one of you and wish you all the very best. These are testing times, and if there are any questions, I would want to take them now.
Thank you so much, Mr. Ranganath. You can stop sharing the screen so that we can
Yeah.
see you. So, yeah, till such time that the audience is sharing their questions, I do have a question for
Yeah.
you. In the coming times, we're going to be seeing a lot of geospatial data coming together from several servers, sometimes even placed geographically in remote areas. This calls for a centralized panel management for security and investigation purposes. Would such a system be a cause for concern? And what is the solution if so?
Yeah, this is a good question in the sense that our belief almost 6 years ago was that the world is going to be very edge centric. We are saying that there are going to be about 25 billion devices which will all be connected, which connected means they are essentially computing or connecting a lot of data. And there is a need for computing at the edge. There is a need for computing at a core level, and there is perhaps computing that needs to be done at a in clouds as well. So it is good that we have the ability to compute. What is really emerging is more of a sense of decentralization, and then whatever needs to be at the core is what is coming to the core today. So whatever be the case, whether you want to get all the data into a single repository, or you want to keep some data there and only send refined capabilities across the board, there are computing technologies which will allow you, one, to kind of compute, or to store, or to manage, or to kind of redeploy in case that's needed. So it's completely doable in today's context.
Great, great. That's good to know. Thank you so much for your time, Mr. Ranganath. And we hope that we can engage with you more as an industry. The geospatial industry can
Absolutely.
engage with HPE for its computing and server requirements.
Yeah, as I said, I have some personal interest as well. So anytime, anywhere.
Great.
Thank
Thank you
you.
so much. And with that, I would like to now invite our next speaker, who's Mr. Abhijit Ray, Senior Manager Pre-Sales Solution Architect from Dell Technologies. Abhijit is a technology leader with vast experience in IT industry, having worked across government, PSUs, and large enterprises in India and South Asia. He's been with Dell Technologies for 11 years and in the storage business for more than 15 years, having worked in organizations like VMware, HPE, TCS, and HCL. He currently leads the pre-sales solution architect team for enterprise customers in Dell Technologies and has played a critical role in solving customers' data challenges and providing business value through innovative IT solutions. I welcome you, Mr. Ray, and now over to you.
Thank you so much, Megha. Hope I'm audible. Just a quick yes or
Yes,
two.
you are audible.
Thank you so much. So in the last, I would say 40 minutes or so, which word got repeated the most? I think it's data, and makes my life a bit simpler to explain the importance of it. Let me quickly share the screen. Is it? Can you see it?
We could see it some time back, but now we can't see the projection. Can you try it again? Yeah, now I can see it.
Okay, thanks. So, good afternoon, everyone. Hope you and your families are doing fine and staying safe. Today we are going to talk of storage solutions for Geospatial 2.0 at a very high level. Okay, so in the next 20 minutes, what I'm going to do is give you a peek into the future, which we are calling as the digital future. And then we'll go into some of the Dell infrastructure solutions, primarily into storage. Obviously, we had great insights coming from Agendra as well as Ranga, setting the stage for us. So on storage, we'll cover the primary storage as well as the unstructured storage. I'll lay out the differences and some of the critical consideration factors as you look at designing solutions for geospatial. Some of the conversations which got alluded to, I will probably delve a bit deep into how you can think of designing something for the edge, core, and cloud, and we'll summarize with some of my thoughts around it. Right. So with that, let's move to what we are heading into. So we are heading into this world of Geospatial 2.0, okay, which is creating basically a better digital experience for humanity. I would put it that way, right? So using the new location-based data, okay, how do you capture the life of citizens, civic bodies, government, organizations, departments, corporates, and enterprises, helps solve very critical problems of water, electricity, transport, waste management, video surveillance, safety and security, and above all, human life. We've all seen what COVID has done to us and how some of those applications have helped us, correct? Including the government's Arogya Setu app. And to what we are already testing out, right? So the last couple of weeks, if you have read the news carefully, there are certain state governments who have already tried supplying medicines on drones to some of the remotest corners in our country, right? So that's what is alluding. And behind all this, so while all this is something that you are able to see and recognize, so behind all this are multiple and heterogeneous ecosystems, okay, which have to be adaptable and scalable, okay, because you're building something not for today but for tomorrow. And ultimately, with all the data that is coming in, you will drive greater insights to kind of help in a faster decision making, okay. And while you're dealing with data, obviously, the data security is of paramount importance. I couldn't agree more with what Matt Sheehan has said. The real value of Geospatial 2.0 comes from data and the insights that can be derived from data, right? So the right combination, with that context, we clearly understand that the right combination of data and software does enable digital transformation, and that is digital transformation for geospatial, correct? And a prerequisite for digital transformation is, from an IT perspective, is IT transformation, okay? And you cannot do IT transformation without really modernizing IT, right? So that's what we look at. How do I modernize IT so that I can run my legacy applications as well as the new applications and the workloads that I will be bringing in with the help of geospatial, right? And all this need to coexist in a multi-cloud environment, right? The moment now when we speak of a transformation or a digital transformation, okay, it has been often, I would say, it has been often accepted that cloud is the way to go, right? And cloud definitely has been, there's been a lot of buzz and attention with cloud, with many organizations and CIOs having a cloud-first approach. Okay, nothing wrong with that. However, we need to be careful because it can create certain challenges if not done correctly, right? So, challenges of data access, data latency, data gravity. Okay, obviously, access and egress costs, compliance and control, data lock-in, and things like those. So, not to take away anything from what cloud can deliver. Obviously, it should be part of the strategy, but the mindset should be of a data first, right? And the data first mindset will definitely drive the right cloud strategy, because the real value of data is our asset, okay? And data needs to be in the right place at the right time with the right SLO to help us derive the maximum insights from the data. So if you look at it, at the end of the day, you have applications and workloads which are bringing data to life, right? So you have these traditional applications which you have run in our enterprises, in government organizations, in bodies, okay? Digitized records, relational databases, physical virtual worlds, the ERPs and things like those. I mean, we've done that for years together. The next gen applications are already on. We are talking of Internet of Things. We are talking of real-time analytics. We are talking of batch analytics, AI, ML, creating those digital experiences. So when you think of an infrastructure that you're planning to build out for geospatial, it is a convergence of both kind of applications, right? And that's where you need an infrastructure to support both the worlds, right? And talking of that, Dell Technologies has obviously plays a great role in this entire life cycle of data. If you were to talk of the life cycle of data, it is from the time the data gets created to the time the data gets deleted. Now, there is no standard definition to this life cycle, obviously, but we all know that it goes through these phases. So you have a data ingestion period, it gets stored, and then it is securely managed and processed so that you get the value out of it. Then it needs to be protected because obviously you don't want data to be exfiltrated to outsiders who should not be having such access to data. And finally, the critical piece is the analysis part, which obviously a lot of it happens real time, and much of it can happen post facto also. Okay, and finally, you find a peaceful way of retiring the data as well, right? So, if you look at the entire life cycle, that is where Dell Technologies as a company comes into play with its entire and complete portfolio of powerful, efficient, and reliable infrastructure. Okay, the infrastructure solutions include the best of breed hardware and software solutions comprising of data storage, servers, data protection, converged and hyper-converged, and networking, right? As a part of this, I would delve a bit deep into storage. So if you were to build out something from a storage perspective for your next generation data center, considering what you're trying to build for geospatial applications, what are some of those considerations that you might want to have, right? So I'm getting into some of the design philosophy of what you should be thinking when you build out a primary storage. So as we saw, it should cater to any workload, because today you are dealing with multiple applications. So it could be a block workload, it could be a file workload, it could be a containerized operating system, a containerized environment, a physical or a virtual. The storage should be able to support all these different kind of workloads with ease. Second is, many of these projects might initially start out as a pilot project, right? So you should have a way of expanding in the future such that your performance can grow linearly as you scale. So the architecture of the storage should be such that it should be supporting both scale up and scale out with typically end-to-end NVMe based architecture, because that's what the latest and greatest, and it helps you stay on course from a technology standpoint. The other point about data is it will continue to grow, correct? So and that is getting ingested by the minute, by the second, and it will continue that way. So how do you derive more efficiency from the same storage system? So that's where data reduction capabilities come into play, and that should absolutely be a top of the mind or a top criteria to be considered for designing a primary storage solution. So this will help in driving a lot of efficiency. But traditionally, we have seen that when such technologies of efficiency come into play, we tend to compromise on performance. So the new storage design philosophy should handle performance as well as efficiency in the same breath, right? So one should not compromise the other. It should obviously be a flexible architecture. Obviously, we will have an agile software development platform on top. You could be using your own programmable infrastructure, or you could be using some of the other cloud platforms through which this storage technology should be able to easily integrate. Now we speak of building AI ML applications and solutions, right? Have we thought of embedding those into the solution itself? That is what is available in today's storage technology, right? From autonomous being very autonomous, in the sense any new workload, it automatically decides which is the right place where I should be landing this workload onto. Obviously, for such large and critical setups, predictive analysis and support is very, very critical. So smart monitoring, reduce your risk, and also predict the future needs is absolutely critical in this kind of a setup. And from a deployment perspective, it should be easily deployable, whether it is at the edge or at the core, or whether we are building out a cloud infrastructure. So some of the solutions from a primary storage perspective that we have at the very high end, obviously, I'm just building out the slide. At the very high end, we have the PowerMax storage systems built for massive consolidation, three data center solutions, zero data loss, mission critical setups, has been running for ages together, and a gold standard when it comes to replication. We also have software-defined storage platforms for the modern data center. The new kid in the block, and which has been ringing the bells of every customer nowadays, is the PowerStore platform, which is absolutely modern, ticking all the check boxes that I talked of. End-to-end NVMe based scale up and scale out, support for NVMe as well as storage plus memory, supporting high rates of deduplication and compression, going as high as 4:1, right? Realistically. However, not all workload is equal. You might still require, spinning drives or large capacity drives depending on the environment, or depending on the use case, some of the surveillance technologies, right? That's when Unity and PowerVault will come into the play. Now, this was about primary storage. I want to bring your attention to the other flavor of storage, which I talked of, right? Which is the unstructured storage. Now, think of the data which is coming to you from surveillance, from drones, from GIS, audio, video files, the IoT and sensor data, right? These are very different data sets. Okay, not typically that we have been used to in a typical data center, right? That's what we are calling as unstructured storage. And obviously in this, when you think of designing, and both of them are critical in the design of the geospatial landscape. So when you think of an unstructured storage solution, you would definitely need to have this multi-protocol access, because what you're building out today and for what you're building out for future, it should have support for the normal, NFS, SMB, obviously those are standard, but support for Hadoop, support for object storage protocols like S3, REST API, FTP, HTTP, very important. And why should I have separate systems? Why not build an integrated approach which can support multiple protocols, right? So that's one of the critical dimensions when it comes to design for unstructured. The second critical thing is, if you look at this data is being generated at the edge, and the scale is extremely high. 75% of the data that is generated in our universe is all generated by you and me. So you need to have a platform which is, someone talked of exabyte scale. Exactly. So it should be able to start small and have a limitless scalability. Okay. It should be resilient, because these kind of large data sets you would not be able to back up typically. So the infra that I build up has to be self-resilient in terms of handling such node failures. And obviously this would be multiples of such nodes that you cluster together to build this kind of a setup. So it should be able to sustain those multiple drives, multiple node failures and things like those, giving you 6 nines of availability. And since we are talking of petabyte scale, if you just keep adding without being efficient, then many of the projects don't fly. So ultimately we have to drive efficiencies through data reduction technologies as well here. And this is where Dell Technologies comes in with the unstructured data storage platform. The PowerScale family is the scale-out NAS solution from Dell Technologies, helping large video surveillance use cases, big data analytics across many industries, and certifications across many of the verticals. We work with multiple ISVs, and you will find certifications if you search up. Similarly, on the object platform, and extremely scalable, we speak of 1 data center, 2 data center, 3 data center. This has been tested and certified across 8 data centers, going up to exabyte scale, thousands and thousands of nodes, and giving you the best cloud economics when it comes to object storage. Right? The other piece, the other interesting piece of this platform is something which got alluded to as a part of our conversations. Data coming in from drones, IoTs, and things like those. What kind of data is that? That's all streaming data. That's all real time, right? So you need a platform which can ingest and analyze that high bandwidth of data in a very economical fashion, which can sit at the edge locations. And that's what Dell brings from a streaming data platform perspective. Now, I know I spoke of many things, and building a storage infrastructure obviously isn't easy because there's data at the edge, there's data at the core, you're building out a cloud, you have to connect things, and there are challenges. Every application demands different set of things. So let me kind of simplify with a kind of an approach, okay, which Dell Technologies tends to follow. Speaking of location flexibility, we now have a great solution for expanding into the edge use cases, such as capturing data from sensors, IoT, and drones. You need a lot of bandwidth to handle those kind of streaming data, and also to fit the density and performance and the bandwidth requirements. Right now, in the core, you need something which can auto balance. Right, so it should be able to auto balance, bring in the relevant data to the core, analyze it, tier it to the right infrastructure. It could be all flash, or it could be the hybrid storage, or it could be the cold archives. So tier it to the appropriate place. You need to have a node-based architecture such that you don't have any hotspots. The entire data gets rebalanced across all the available resources, supporting all the multiple protocols for today and for future, right? And finally, because this kind of data cannot be migrated, it's not easy to migrate such large volumes of data. So the newer technology which comes in should be possible to add to the existing cluster itself and retire the older nodes. So we are thinking of an architecture where you don't never need to migrate out of this, right? So that's what Dell Technologies brings to the table. And obviously, finally, you could think of tiering to the cloud. Many of the applications you could also think of directly hosting in the cloud, and Dell Technologies has storage solutions for the cloud. And obviously, tiering to the cloud is an important aspect. When I speak of cloud, obviously, cloud could be on-prem, it could be public cloud as well, right? So speaking of cloud, the way I want to leave you with is cloud is not a destination, it's an operating model. But we started off with the philosophy that you should have a data-first mindset. And the data-first mindset makes us believe that we need to take care of three things. Okay, first and foremost, the law of physics. That is the idea of data gravity, right? So wise strategy for you would be for IT to gravitate towards the source of the data. Okay, so that latency is not an issue. Okay, and we have seen that we haven't found a way to go beyond speed of light. So the more closer you are towards the source of data, you tend to deliver better experience to your end customers, right? The second is the law of economics. As with any other investment, there is only a finite amount of resources available for our IT infrastructure, right? And even the most advanced and useful technology can be shelved because of economics. And obviously, economics has to be looked at both from a capex as well as consumption perspective. Both might make sense depending on what you want to evaluate. But however, there could be situations from a TCO perspective where a capital investment can turn out to be better than consumption economics on a long-term horizon, depending on, again, the kind of data sets, the kind of application that you're dealing with. And it could vary. And obviously, the last point, the laws of the land, data compliance, security, and governance are important criteria. While government is opening up, they are equally cautious about data protection policies, okay, as they become more and more data savvy. So from my perspective, clearly believe that it's not one versus the other, it's probably both. And you would need to operate in a hybrid environment. So in summary, Dell Technologies has a comprehensive portfolio of solutions, breadth of innovative and modern storage technology to help you in this geospatial data management part. These solutions are very smart, efficient, and intuitive. So you spend less amount of time and energy and resources managing it. And finally, Dell has the IT experience and the storage DNA to be a reliable partner in your journey to Geospatial 2.0. Thank you. So this is what I had to share. I'm open to questions, if any.
Thank you, Abhijit. Very good presentation. I think it gives a lot of understanding of the storage and the requirements that we need to be looking at for developing a storage capacity. So I have a question for you. With regards to edge computing and edge workloads, what kind of innovation has Dell done on storage solutions?
Okay, interesting question, Megha. So obviously, Dell is investing a lot around edge solutions. We also have rugged devices which can sit in factory floors and the harshest of environments, taking up maximum temperatures possible. But typically on storage, I want to bring out a differentiating factor such that, today we have the capability of running for very small landscapes, compute directly on the storage. So that's a great innovation, the first in the industry to do so, and a great use case for edge locations, because you might not want to invest separately on compute, on infrastructure, on a SAN infrastructure, and then on storage. So it's a dense, and these are typically performance hungry. Many of them are performance hungry setups. So having data close to the compute, running compute directly from inside the storage, because of the virtualized and the containerized operating system that we have on the latest storage platform, is a great innovation and a great boost for such setup.
Great. Thank you so much for your perspective and for joining us, Abhijit. And with this, I would like to now invite our next speaker, Mr. Sanjeev Jha, Principal Smart Infra SA from Amazon Web Services. Sanjeev is also a part of the Governing Council of AGI. Sanjeev is he is a senior data scientist and enterprise architect with 25 plus years of IT experience. He specializes in developing cloud and data-driven strategies for decision-making and monetization by leveraging expertise across AI, deep learning, data lake, IoT, satellite imaging, and geospatial. He has worked across key public sectors and high-growth areas such as smart cities, smart agri, pharmaceuticals, and digital advertising across business stages, that is startups, growth, and maturity. Over the years, he has been associated with top startups and Fortune 500 brands such as Quantella, Personograph, Pubmatic, Comly Media, Yahoo, HCL, Quattro Wireless, Symantec, etc. So with this, Sanjeev, may I request you to please switch on your camera so that we can see you? I think you're muted. Sanjeev, can you please switch on the microphone?
Yes. Hi, Megha. Thanks for
Hi.
the intro. You can hear me okay?
Yes, yes.
Awesome. Thank you so much. And I will get it started. So, yeah. You can see my slide deck, right?
Yes, we can see it now.
Awesome. So, very good afternoon, all of you. And today I want to talk about how you can build a web scale geospatial stack on cloud. See, I'll start with a small reference architecture. It's a kind of, I'll call it a 1,000 feet architecture for a typical geospatial stack would look like. So in the middle, you can see the 4 stages of, once you have collected the data from different sources, different means, drones or aeroplanes or satellite, that data has to be collected and put in a compute environment, here, namely cloud, for example. And then it goes to a production pipeline where you have to kind of do some pre-processing on data. And once you have pre-processes and you got in kind of raster formats or your vector format, then probably some kind of software to add more level of details depending on your requirement. You will use various software to add that detail, and finally dissemination of that information or publication. And you require certain horizontal capability, AI, ML, through all these layers, as well as it has to be secure. And you require a huge data storage. So I'll talk about a little bit tier storage strategy, how you can keep your price lows, and how you can leverage cloud, and also the orchestration layer of how you can create a workflow across that. So next, talking about data collection, when you have collected this data, you have collected from satellite, drones, and etc. It requires a very high connectivity, and you got a different kind of tools to make sure that you seamlessly transfer it to a cloud, for example, or to your data centers. So namely, cloud I'm talking about, and I'll use AWS construct as a reference. The concepts, are pretty cloud agnostic, but I'm going to use AWS as a reference. So from AWS perspective, the concept of like direct connect your on premises and direct connected dedicated lines, which is provided, which is a high connectivity fiber lines, which you can connect to a data center. So for example, in AWS, the data center is in Mumbai, and there's a 6 direct collection locations across the countries to which you can connect, as well as there are some, a point of presence with like 26 point of presence all over India. One can leverage that, and it can give you up to 500 GPS connectivity. And then there's like a storage gateway, which is kind of in a structured way of automatically doing data transfer. You don't have to worry about connection loss and etc. And then various other family of services which AWS will provide, which makes sure that your data is in sync. It is being being transferred to the cloud on accelerated manner, and you are not necessarily all the time. You have to leverage the public internet, so it's secure and faster. Once you have moved your data to a cloud in a secure manner, then you want to do some kind of processing. You want to do some pre-processing of those data. You don't want to do auto rectification or any other those activity, and that requires a huge parallel compute, and that's what you need. So a typical in a cloud environment, you will have on-demand systems available, and you can leverage these cluster management software where you can scale out your clusters on demand, and you only pay how much you had used. I mean, that's kind of versus of like on premises where you need to own the infrastructure upfront. Here you are not need to buy infrastructure upfront. You are using it dynamically. And as I take an example of AWS infrastructure here, AWS has these 5 pillars where they enable high processing compute. AWS Cluster is a cluster management software that the whole instance of variety of instance of compute you can use, which can be a GPUs or non-GPU systems or cloud, memory optimized or compute optimized, and all these clusters require a very high connectivity. And that is the electric fabric adapters are. And also you require probably a distributed file systems. So AWS has provided Luster, which is a distributed high performing file systems for the to give you high performance compute. So once you have done your pre-processing and probably you have the files in the format of your raster file data and some in a useful format on which now a different kind of softwares can be applied. Often, people put a GIS experts to add a level of detail to their data sets and geospatial data, and they will leverage various kind of desktop QGIS or ArcGIS or some AutoCAD or many other point cloud or other kind of manipulation software which are in desktop. And often comes to your mind that, hey, if I have a desktop, then how I can leverage cloud. And you have already put a lot of data on your cloud, and you cannot afford to download it all the time and do that processing, right? So the way to do it is that, for example, AWS provide app streaming capability. So you can actually have your desktop instance being created on cloud, and you can using, for example, app stream, you can actually manage your desktop through a browser. And it's kind of BNC and that kind of you're familiar with. All your desktops are screened to your browsers. You can do it actually multiple screen capability as well. And some of the, like for app stream, for example, provide you can have options of putting pixels and granularity you can want to put up, those you can put in as well, and your data remains on a cloud. Desktop has been launched on a cloud, so that there's no latency of data issues here at all. Moving on, once you have actually now done your creation of data and you want to kind of disseminate that data, And so how you do that? For example, you might have a tiles of multiple GVs, and you cannot download those data again from the cloud and process, or have those entire data sets move to across the internet for dissemination or sharing. So best way is using the cloud optimized GeoTIFF format. And that is to enable the cloud workflow, which we recommend to do it. And many of in fact, all this Sentinel data, for example, or any of this satellite data which has been put on AWS is in a COG format, which is called cloud optimized GeoTIFF format. And what is this GeoTIFF format is basically the internal structure of data has a location being kind of integrated. So you can only require your area of interest, and that only piece of data get transferred essentially over the internet. And it's very useful with HTTP kind of get range request kind of or protocol, where you don't have to have the entire data set being transmit over the internet, but only the part of it in fact. Okay, so that's kind of optimize how you can do a data disseminations and publications, and all these standard GIS like Geo servers or ArcGIS publishing servers, or many of these standard actually support that. Or if you're familiar with Dell, they support these format as well. So it's getting more acceptable. Initially, it started as a satellite image way, but now it has been extended to many other kind of data format. Lastly, in that topic, when you have a data on cloud and you have large small scale of data, then you have to catalog that data. And a spatial temporal asset catalog is a standard or a specification how to do that structuring in a standard way. And as mentioned, most of the satellite data on AWS are published in a stack family, a specification. It started with satellite imaging, but now it has been getting widely used on Earth observed data or GIS data, I should say. So these are kind of, some example of format which is kind of evolving, a standard which is evolving how you can actually do the dissemination of data through cloud and don't get bogged down by downloading, big chunk of data. Now now let's talk about few of the horizontal enabler technology on cloud in your reference architecture. So talking about storage. So now with all this innovation of technology through sensors and drones or aeroplanes and satellites, you have huge data, and then if you have the data to scale to a country level or even the world scale, you require a lot of storage, and that costs a lot of money. So what we recommend on AWS that leveraging the tier storage concept. So AWS has a concept S3. S3 is basically an unstructured object database, and it's a very cheap database. And then use that in connection with little high performing data storage like network file system and Lustre I talked about earlier, or other kind of storage system which are expensive but very fast. And these clusters will require those, do a processing and move it to a cold storage, or you can actually do a put a policy of that data. You can put up life cycle of policy, which then this cloud or AWS namely will move your data across a different storage to cut your keep your pricing low. So AWS, for example, has a multiple kind of storage available. So I'll talk about S3, which is the object database. Then you have block database, the network file systems for cluster uses, which is here, and automatic backup as well. And also there's some edge databases also is available. A storage gateway is a means of connecting your it's hybrid environment. The lower one is all hybrid environment, where you can have your own premises databases synced with the cloud database in seamlessly and transparently. Once you have the storage being settled on your environment, then you talk about AI ML infrastructure, which you need widely across these different layers. And cloud in general provides a portfolio of these infrastructure which you can use on demand. So you don't have to buy upfront, and you know, these technologies are evolving. It's, you know, rapidly evolving. New technologies come, and as we go, you know, we require more and more of these. The requirement never ends. And when you know go to a cloud environment, then you're not stick to one technology, but you stick to a one which you have invested upfront. You can actually dynamic goes, and you can, you know, keep adding or changing your storage. You know, I'm professing a data scientist, and I do that very often. When I did some model and it takes me say 1 hour, and I say, oh, is this too much time? Let me upgrade to a different system. I do a click a button, I upgrade to 64 GB GPUs, that my time has reduced 30 minutes. I know how much it taken, a few minutes, versus probably a month it would have taken me to procure physically. So AWS, talking about, has a portfolio of machine learning accelerated compute that is starting from GPUs, which probably expensive side, and then, you know, Nvidia base, and then also, like, you know, some Intel's new you know, instances are coming up. And from an inferences side, AWS's own chips called Infi1, you know, which is the cheapest one, lowest cost per inference in the cloud, and so on. So it's you know, the messaging I want to get to you out of this particular slide is that there's a portfolio of compute, accelerated compute, which you can pick based on your budgets as well as a need. And also, you know, to give a small glimpse of, you know, what AWS ML stacks are available on AWS. On the bottom is the infrastructure, and then there are ML services, which, you know, if you are a data scientist and you want to manage your workflow, and you know, the whole process of modeling, that's where the SageMaker come, which from doing a ground truthing to developing a model to, you know, training, and then also deploying, this entire processes can be managed by that. And on the top, which you're seeing basically ready-made AI services through API. Here, you know, you don't have a, you know, big data science knowledge you require, but you can leverage many of these services to do your data science workload, and everything behind, right? Any infrastructure needs are being taken care of by the AWS infrastructure. I mean, just to point out few, not to take much time here, like a recognition of the video analytics. Then, you know, you want to do, like, you know, Alexa kind of capability as a speech, you know, chatbot, and so on. And I didn't mention here is there's AWS location, which is basically a geospatial capability, which from mapping, from point of interest, and etc. is also available out of the box. So moving on, you know, we're talking about, like, the security here. You know, what we call in AWS security is a job number 0. You know, every layer you can, you know, AWS has a security, and it is flexible, and the command and the control is given to a you know, customer. The customer pick and choose and can decide that what level of security you want to, you know, have. And all you see the boxes are basically AWS services, a capability, which you can actually configure, and it will support you the entire life cycle of the security. Like, that is kind of identifying, protecting, detecting your responses, automated responses, and recovery from any of the security issues. That is, like, you know, snapshots or archiving capability. So I'm not going to go detail of each of these services. You know, I'll just leave it to you for, you know, your own exploration. But the point I'm trying to make is that there is a bunch of tools available on AWS, and in fact many other clouds as well, where you can have a security from level 4 to a level 7 to applications, and also kind of you can create whole kind of, you know, cloud watch or kind of, you know, cloud trail kind of services, which will keep watching and giving you kind of auditing on your security of your services and platform. You know, so that's kind of, you know, I can give you, you know, to summarize, I gave you a kind of sense of that, taking this reference architecture as a kind of, you know, reference to describe you the different aspect of a geospatial stack, which you can create in cloud in a low code or in sometime a no code kind of, you know, paradigm. And I'm obviously left out many other capability, that is from CI/CD capability or container capability. Many other I have kind of skip here and just kind of focus on the core of a geospatial stack. With that, you know, based on, I thought I'll share with you a few things, few data, then based on our thousands of migration experience on AWS, and we have seen across a variety of the customers, they have actually achieved much benefits, for example, reducing infrastructure cost or fewer security accidents, more productive, IT staffs, or more features which you can deliver, because when you are in cloud, you are less bothering about the operation of the platform and more bothering about your new features or new development work, and that's why you can do more features and not worry about keeping your light on while you have done your infrastructure in cloud. And I will leave you with a small thought that, hey, I decided to do migration or modernization success. What makes me, what 2-3 things I should take care of to make sure I'm successful. Based on all these, thousands and thousands of, migration and experiences, we think 3 things are important. First is a planning. You plan your portfolio and create your roadmap for cloud journey. That is extremely important. And we say that, if, typically 9 months, which is a cloud life cycle journey, is, and first 3 months is more about having your team being ready and your plan in place, and then come with your operating model in a cloud, which is, is a different mindset than what your promises are. Cloud is more about horizontal scaling, more about, dynamic and agility. If you don't have it, then you will not get the benefit of what cloud is to offer you. And we thought, we kind of advise to all our customers and partners that, if you don't have whole IT expenses, then don't worry about it. The cloud has, or AWS has, for example, 7,000 partners in India itself operating, and it's a very strong ecosystem. And get a partner, or obviously, there's whole solution architect teams in AWS as well, who can help you with the planning to kind of implementation and hold on you in that particular journey. So with that thoughts, I'm on the end of my presentation and open for questioning. Megha?
Thank you so much, Sanjeev. So we have a question from Mr. Sumit Sen. He's asking, could we use this GeoStack for a POC using a free license?
I don't totally understand what the free licensing mean here, but definitely AWS has a free tier, which they provide certain set of level of compute or storage and some kind of API service I mentioned about it as a free of cost. So you can actually leverage that. It will be a very small scale as well. But in general, if you plan to do some kind of POCs, most welcome connect with the AWS business development team, and they can help you out.
Great. I also have a question. Can you talk a little bit about data safety on AWS as between on-premise data center and in cloud?
Yeah, surely. So, on AWS, I mentioned about their security stack and different services. So each data, let's say if I'm an AWS, then each object is object database, and each object has its own accesses and all permissions. And it depends on the customers to give what kind of permissions, who can take that data, who can have an ingress, who can have an outgress. All those are configurable and in the hand of the customer, and they can set and dictate what is accessible and what is not accessible. Similarly, there's also a concept of VPC. It's called Virtual Private Cloud. What that concept means is that if you have set up VPC on AWS, the entire infrastructure which you have created within VPC is yours, is only visible to you, nobody else. So, so that's coming. Say it is literally is as secure or maybe more secure what data would be on premises. And plus, Megha, before I conclude that, AWS also has a global infrastructure. So like when I talk about in India, you have a Mumbai region as a data center, then also have the availability zone, and these data get copied automatically to a multi different location. And this is one of the advantage on cloud infrastructure, AWS namely, where you don't have to worry about this backupping and data on every, and you don't have to incur the cost for that. The infrastructure take care of that. So also it has all automated replications of data. So it is always be available with at least 99.9995% guarantees.
Great. Thank you so much for your time, Mr. Sanjeev, for joining us. And thank you for the insights that you've shared about AWS and about cloud infrastructure. Now, I would like to invite our next speaker, Mr. Unnikrishnan AR. He's a head developer marketing and cloud service provider business from Nvidia. Currently working with Nvidia, Mr. Unnikrishnan focuses on building and executing strategies to grow the Nvidia developer ecosystem, driving Nvidia Deep Learning Institute business and growing cloud service provider business in the region. Prior to Nvidia, he worked with the semiconductor and IT industry in leadership roles across sales and marketing, product management, and strategic planning roles during his tenure at ARM, Cisco, Intel, Silicon Graphics, etc. So over to you, Mr. Uni.
Thank you, Megha. Let me share my screen. Hello, everybody. This is a great opportunity. Thank you, Megha. Thank you, Agendra, and thank you, AGI, for this opportunity. I wanted to take a minute to sort of put a perspective to the presentation which I wanted to make today. So there are powerful forces currently at work, which is sort of changing the nature and shape of everything that we know, including the industries. And to put this in perspective, I thought a quick 2-minute video which sort of defines the state of the art in AI would be a good idea. So please enjoy. AI would be a good idea. So please enjoy.
Mr. Uni, the volume is not very clear.
Clear now?
Not really.
Searching for the origins of our universe.
That's good.
And charting a safer path to other worlds. I am a helper, moving us forward one step at a time. A safer and giving voice to every emotion. I am a healer, modeling the future of medicine. And finding the needle in a haystack when every second counts. I am a visionary, uncovering masterpieces lost to the ages. And finding new adventures in a galaxy far, far away. I am a builder. Driving perfection in everything we create. I am even the narrator of the story you are watching. And the composer of the music. And when the world faces its greatest challenge, take it on together. I am AI.
Thank you. So I hope this gave you a good perspective of what's happening, right? But if you try to compartmentalize it, there's basically three huge revolutions in front of us. IoT has been with us for some time now. We expect around 150 billion odd devices, IoT devices in this world by around 2025, which will grow to something like 1 trillion by 2035, in just 10 years. 5G is going to fundamentally change everything that we know about bandwidth and telecom. It's going to be at least 1000x faster than the current generation technologies at latencies which are single digit. It will just make real time, the way we know it, real time. We can download movies, high full definition movies in seconds. You will not be in a position to realize and recognize what is remote and what is near, and operate and enable IoT devices to areas and environments which you never could have otherwise done. And fundamentally, all this is going to be accelerated and enabled by AI, which we are already in knee deep into the revolution which AI is building in. Economically, AI will pretty much get us into something like an impact of $1 trillion plus per year. These are the three of the most powerful technologies and revolutions which is happening simultaneously in front of us. And we are very fortunate to live at this point of time, right? We are pretty much in the age of AI, 1 trillion connected things. As it is, as we are speaking, 2+ million factories are getting connected. There are 13 million plus stores which are getting automated, 570+ million farms which has already moved forward, connected, Internet of Things enabled, call center agents, 5+ million. We have AI vehicles now driving 40 million plus roads. 110 trillion plus kilometers has been driven by the pursuit of autonomous AV vehicles. But if you fundamentally look at it, AI is what you're seeing in the screen. You have devices which they're sensors which capture the environment. The neural networks which is being trained is now in getting the data from the sensors, and it perceives that environment. And then, just like the robot which you're seeing in front of it, it can perceive and reason with that environment, and then leverage the actuators which it has to make the action which it is supposed to do. And the cycle continues with the new data. This is true for any domain which you're working on. Same process applies, and the same underlying fundamentals enable you to apply AI to every single domain which you can think of. Now, if you break this down into a flow from the data perspective, you have, like most of the speakers earlier have said, you need to have an approach towards collecting that data, to retiring that data, like the speaker from Dell was saying. You do that, and then you do, in the process, after you collect the data, analytics on that data. Before that, you organize it, you do ETL on that data, and then you try to extract features for the particular machine learning model, either with core fundamental machine learning or the new deep learning. And then you construct your models, combine your models, validate them, and then deploy that into the new environment, to work on new data. This is the flow, right? Horizontalization of this entire flow, if I do, is what you're seeing in the screen. Underlying to that is currently used tools which enable you to support that. But if you look at what's happening with all these technology transformations which is there in front of us, which I told you, IoT at the scale and depth which we are having, IoT, 5G, and AI happening, in each of the construct areas, transformation has happened. Data, we have been working with data for some time now, right? Big data has also happened, not so early, but at least 5-10 years now. But the construct underneath the big data started with the idea that, we'll work on gigabytes of data, and we'll work on slices of that data to do an analysis which would be required, let's say 3 months later, 6 months later, depending on the business process which you are wanting. That fundamental has changed. We are now itself looking at gigabytes of that data growing to exabytes, which we already have reached in many industries, many areas. Mobile internet has just exploded that. we also want to do real-time analysis on that data rather than doing it 3 months later. We also want to do it with the full data rather than slices of the data, in order to enable the latest generation AI models and also to do the level of work which we want to do on analysis and prediction. On the feature side, with the discovery of deep learning and the interest which has happened in the 3-4 years back, it has completely transformed our approach to AI, to the model which I've just discussed now. There, again, the complexity of the neural networks are exploding, and you also have enablement of this now across multiple functions, where each one of them are crossing over superhuman capabilities. With that, you need to now enable them to talk to each other, because you're now in a world where the machines are starting to talk to machines more than you talk to the machines, or you talk to other human beings, and you need to combine them and then deploy them into an architecture where you want the AI which you've built to operate an environment. So you architect that, and then you deploy that for a scale which is unprecedented. So that's the full flow which you have for the data. Now, if you look at the underlying infrastructure which you need for that, the first part of it, right, to create the model and then combine them, you need supercomputing class machines, very powerful machines, because training that AI model is extremely compute intensive. Storing, analyzing, and training that model part needs that high infrastructure. Your enterprise data center needs to transform to support that level of scalability and high performance requirement. On the other side, where you are deploying this deployment would be either in a hyperscale data center to the millions of instances of that new AI which you have built, or in the edge device, or in a combination of both of this. In the edge, it could be a robot, it could be a drone, or anything which moves, which tomorrow will be autonomous. In the case of a hyperscale data center, it will be a millions of customers inferencing on the millions of instances which you provide with underlying servers, either in your private cloud or in your multi-cloud environment, which you go for from multiple providers. This is your infrastructure, and this is how you'll build and deploy the model across any type of environments. I see you see here is for autonomous driving, which is one of the most complex environments, incorporates geospatial also into it. Same thing is true, but otherwise also for what you within the geospatial industry do on a regular basis. Most of the use cases which you do, urban planning to object segmentation within the geospatial territory to creating digital twins of Earth or the universe for that matter. Now, if you look at it, the underlying fundamental thing which has changed is in the age of AI is the code constructs itself. The entire infrastructure play itself has shifted. Like I said, the data has exploded and has become the core fundamental value proposition for enabling these processes. Data is your new oil. Then you have algorithms which are developed by the scientists for these new functions or existing functions in the new ways, and they are being discovered on a regular basis, and there is a compelling explosion of them happening. As we speak, the model complexity within each of these algorithms are also exploding beyond the number of models which is coming. So that's the second ingredient. And the third core factor is to get the compute or the compute required for enabling this algorithms with training, rather these algorithms with its data. These three components are your core fundamental infrastructure for the next generation of your IT requirements for enabling your enterprise. Within that space, now if you look at the development which has happened in the just last 5 years, 2015, AI enabled us with superhuman image recognition. 2016, it gave us better than our capability for doing language translation. 2017, better than us speech recognition. 2019, generation of speech better than us. By 2020, it gave us language reading comprehension capability better than us. And we are moving at a pace which is even aggressive on component functionalities, which AI is getting better than us. Baseline, AI is the most powerful technology force of our time. It's enabled for us human level reading comprehension now, chatbots, which is literally getting into a position where we are not able to recognize it's a bot at the end of it. You're getting in your own environment, and with the policy which Agendra and team was talking about, you'll have drones delivering for you, which are safe and precise. You are able to now almost get an end of this pandemic in a time which would have otherwise been absolutely impossible. Our drug discovery pipelines, which has been typically 6+ years and billions of dollars, is shrinking to 2+ months. You're having walking the robots, which can now literally navigate any type of terrains. But if you look in on the underlying factor of it, you'll find that the neural network complexity which is there to address these type of neural network requirements and AI is exploding, literally, right? 30,000x in 5 years. 30,000x in 5 years. Baseline, the network complexity is doubling almost every 2 months. Now, if you look at the graph which is there on the left side of your screen, you will find that on the typical CNN model, the complexity which is for image recognition, the LexNet grew from 2012 to something like in the region of hyperparameters of the neural network region of around 100 million. But if you could look at that in the case of language, and with the new generation transformer-based language models, the BERT, which started in the region of 1 million+ parameter complexity, last year was in the region of around 150 odd billion parameter complexity. We think by 2023, this will move into a region of 100 trillion parameter complexity. It is just disruptive growth of that level of model complexity. And essentially underneath that, you need the infrastructure, IT infrastructure, to run and manage this. That's a challenge which you have when you move into the next generation in any domain, and in your case, Geospatial 2.0. Nvidia has been a company which has believed that the current compute underlying infrastructure is suboptimal, and we built an accelerated computing platform. We're celebrating 25 years of that, and we now are a three processor company. We have the core fundamental GPUs, which accelerates your core compute in a parallel domain across enterprise application areas and computer science application areas. We have just introduced the data processing unit so that you can look at your entire data center as a single unit of compute. And then we are moving into core compute CPUs so that we can have a tightly integrated next generation machine. We're building a full stack to support this entire acceleration across domains. We're a full stack company now, from networking all the way to compute acceleration, development of software environments to support you in each of these areas. We're building this to support data center scale. And at the core of all this is one single architecture supporting the growth of this compute environment and platform across our developer base. We are today around 2.5 million plus or developers working across domains and environments on this. Essentially, if you think about this, the growth has enabled our scientists and industries with the path forward on AI. For the scientists, it's in many words, many scientists have come back and said it essentially enables them to do their life's work in their lifetime. Look at the optimization which we have done on our suite of software stack, which is accelerated in many of your environment itself. 13x in 5 years across every single application area which you can think about, and then scale them across a huge amount of GPUs, from almost single node GPUs to something like 20,000+ GPUs. And in the case of this third block which you're seeing out here, this is essentially molecular simulation of the largest order which we have ever seen. 305 million odd atoms simulated on NAMD, which is scaled to support growth from 1 GPU to 20,000 GPUs. And this essentially is a simulation. The image which you're seeing is a simulation which is done for identifying the COVID vaccine. And essentially the scientists who have done this was the last Gordon Bell awardees. Effectively, like I was saying, given scientists a time machine. With today around 1 billion plus GPUs in the installed base, around 250 billion odd exaflops of cloud compute now there, around 2,000 plus GPUs, 24 million plus CUDA downloads now, 150 plus SDKs across domains, 7,500 plus startups are working with us across domains. And these startups are selected, and we think they will change the world in the domains which they are working on. These are the core selected startup, not just the full spectrum of startups which we are working with, and around 2.5 million odd developers. We're across both these areas developing technologies at a pace which is unbelievable. These are the technologies which you're seeing, which we've come out with in the just last 1 year itself, enabling disruptive changes and enablement of technological capabilities in those domains. Omniverse enabling you to create full immersive digital environments for your data, fully physics enabled, supported with material across board domains and areas. Our drug discovery pipeline is, just like I was telling you earlier, shrinking the capacity for discovery pathway from around 6 years to something like 2 months. Computing support for quantum was enabled fully on GPUs with our CC Quantum SDK. So we have now full level SDKs and part components for enabling you for conversational AI, recommender systems, full-fledged endpoint to signal level understanding of your security, and full suite of enterprise class AI enabled software stack for you to support on this platform. Full autonomous capability work, which we're doing with our autonomous partners, with underlying technologies on graphics, on core compute, and then enabling 5G with AI. Now, if you look at the underlying core data center infrastructure which is required, the software was originally monolithically running on the data center which you had. And then with the advent of virtualization, you could now, the IT could essentially move this across servers from a single pane of glass, then manage that. With the advent of cloud computing and the scale which happened with the growth of customers and the growth of cloud computing across regions, you could now move this across clouds into disaggregated microservices, with the software now looking at the entire data center as a single unit of compute. With AI coming into play, most of the underlying infrastructure which the AI was running was replaced or greenfield built with GPU accelerated computing platforms. But underlying to all this, in the graph which you are seeing, that gold area is the overload on managing that virtualization, or the overhead on managing the sprawl onto the CPU compute environment. And that's become a big component of the overall compute which is there in the data center. In fact, the single largest overhead on compute in many of the data centers. With DPU, which is our latest innovation for data center processing, we are trying to offload that compute requirement onto this new chip. Let me try to show you what we have done with our own requirement for this. So GeForce Now is our cloud gaming service. What it essentially gives you is real-time cloud gaming on any front-end device with latencies which are enabling you to almost look at it as if it's real-time. Currently, we have scaled that to almost 10 million users across 70 countries. It's a sprawl which is unbelievably complex. As you can see in this graph, you need to deliver this entire compute where your gaming person, you or your child, is actually interacting with the game on the front-end device, and that interaction instantaneously needs to transform into the next level action of the game by going through this value chain which you're seeing and the timeline latencies which is there in each block. Net at a total latency of less than 10 milliseconds. We deployed this originally in traditional cloud services. And as you can see, you had the game running on it, the graphics driver to support the complex graphics on it, the video support on it, and then the underlying SSDC, security, telemetry, NAT, DDoS, reverse policy, etc., connected to with the NIC. What I'm saying is, with the DPU and then the new GeForce Now cloud backends, what we have done is we have offloaded this entire underlying compute on that part to the new Bluefield DPU and taken away that work from the CPU. You now are able to get this work done at line rate. And the CPUs are freed up, CPUs or GPUs are freed up for the core work, which you are able to now more and more accelerate and scale up. Effectively, you can look at your data center as a unit of compute now. We have also the full-fledged SDK for supporting this and deploying this across both your new generation data centers or legacy data centers and reframe them, working with across-board ecosystems to support that, from storage-defined infrastructure vendors to storage, cybersecurity, and edge providers. Essentially, from the infrastructure side, then, as the AI developed and the AI was getting matured itself, we recognized that we needed to build a purpose-built AI supercomputing stack and supporting infrastructure to enable that for our customers. So we went and built NVIDIA DGX platform for that. You have here now on the screen the three flavors of that. Essentially, the DGX A100 is the base building block. You can build the DGX SuperPod with it, which is a data center in a box type of an infrastructure for you to immediately build a cloud native supercomputing infrastructure. Or you have a personal AI supercomputer for an enterprise department level immediate requirement with our DGX station type of system. And pretty much every single enterprise which you can think about has started adopting these platforms for their core backend. The enterprises which are wanting to immediately deploy from whatever they had to a greenfield full-fledged enterprise class multi-petaflop supercomputer, they're just buying a DGX supercomputer because it's ready to run and on day one, right? 0 to petaflop class compute in days. This one which you're seeing has been now enabled in multiple supercomputing sites across the world in less than 15 days. If you want enterprise class production setup in your desktop, under your desktop, you get now 2.5 petaflops of supercompute for AI with 320 plus GPU of storage in a system like this, whisper quiet, liquid cooled under your desktop to enable you with your AI. The requirement for this level of compute comes because, like I was earlier telling you, with the type of complexity which is there and the type of explosion of that complexity happening in the underlying models which is there. And that's what you need to be ready for when you're building this infrastructure. Both on the training part of it, sorry about this, both on the training part of this as well as the inferencing part of it. So in the training part, like I was telling you, the model complexity is growing from millions to billions and now expected to grow into trillions. And when you deploy that into inference, you look at what's happening. You run the latest generation inference model and build it to deploy to your millions of customers. You want to do this in a traditional enterprise data center which you had, you'll run it on CPUs and it will deliver to you one query in greater than a minute's time. Whereas on NVIDIA DGX or A100 powered system, it would give you around 16 queries in 1 second. That's the level and magnitude of difference which you get when you relook at your environment. Beyond the underlying core compute, which I've said, we also build the software stack to support our customers for it and put them into a registry in the cloud called NVIDIA GPU Cloud, which is completely freely enabled for you to download and take advantage of. We have put them from in there the core underlying frameworks to models in key environments which you're wanting to, whether it's in conversational AI, whether it's in computer vision, and then fully enabled orchestration capability for you in Kubernetes environment. Let me take a minute and show you what exactly it means to you and how you can leverage it. Please watch.
Enterprises in every industry are adopting AI to deliver cutting-edge products and services, but they face many challenges. AI is hard, and AI workflows are complex. Data scientists and researchers need easy access to AI building blocks such as models and containers. Developers need tools to seamlessly integrate models into their API or service. And DevOps engineers need tools to deploy and manage these applications across a hybrid infrastructure, which is why we built the Ngc Catalog. The Ngc Catalog is NVIDIA's hub for GPU-optimized AI, high-performance computing, and visualization software. The catalog includes containers, deep learning models, SDKs, and Helm charts to help you start building apps quickly. Packed with the latest optimizations from NVIDIA are deep learning frameworks such as TensorFlow and Packard get your teams up and running faster than ever before. These secure, portable, and scalable containers allow your teams to build and deploy AI apps on premises with NVIDIA certified systems, in the cloud, or at the edge. State-of-the-art pre-trained models are available, ranging from conversational AI to computer vision to recommender systems. You can take these models and deploy them for inference or customize them to fit your specific use case. With our industry-specific SDKs for healthcare, robotics, smart cities, and more, you can easily build and deploy high-quality applications to production. Finally, the Ngc Catalog offers Helm charts that let you deploy and manage your applications on Kubernetes environments. So how can all of this help you transform your business? With Ngc, you can reduce costs by optimizing workflows, deliver incredible products and services faster, and decrease your overall total cost of ownership. Ready to get started? Head over to ngc.nvidia.com.
Effectively, the platform now enables you to have NVIDIA AI fully enabling you to from data preparation all the way up to orchestration. We have gone beyond that now, right? We've also enabled you now standard servers from OEMs fully certified by NVIDIA for complex real-world practical tasks so that you can quickly adopt them into your stack and upgrade your data center into an enterprise class AI ready data center with NVIDIA ready certified data center servers from any of the OEMs which you work with. And then we are continually working with the ecosystem to grow that. And then we went a step beyond that. We enabled and worked with VMware to now give you a full suite of enterprise ready AI software, which you can deploy on VMware with Tanzu support coming in immediate term. This is also enterprise class level supported by NVIDIA with direct CPU level subscription services. So you can grow to build your enterprise AI infrastructure for your Geospatial 2.0 in a fully confident manner, crossing over the risk which you will have in otherwise moving into this stage where you have to build capacity for running your disparate AI components on your legacy infrastructure, scale them, and also provide the high performance which you need for running these models. I'm moving at a little bit pace given the time which we have, but just in short summary, thousands of companies are using this model to now start and build their infrastructure to take advantage of the new generation AI which is coming in. You need to look at moving your legacy infrastructure into enterprise AI ready accelerated computing platform infrastructure for both AI training and inferencing that at scale. In conclusion, AI accelerated computing, AI is transforming our data center requirements. Accelerated computing is the path forward. AI is software that will write software. Data center is your new unit of computing, and AI and 5G will enable Geospatial 2.0, and autonomous is the path forward. Everything that you see which needs to move will be autonomous. In this, I just talked to you in the earlier slides about Omniverse. Omniverse is our software environment and platform for creating multiverse environments in virtual world. You can take your 3D data, geospatial imaging data also, and then put that into NVIDIA Omniverse. You have three core components of it: the Nucleus database engine, which is working on universal screen descriptor across domains so that you can plug your data in. And then you have the core component, compute and rendering engine for enabling that and working with that data in full physically enabled manner, full physics supported across materials and across environments. And then you have NVIDIA XR, which enables you to literally think of it as a Stargate, which enables you and your collaborators to work on that data in real time across geographies. This is NVIDIA Omniverse. What I wanted to do was to give you a quick glimpse of how geospatial industry is using this with a digital twin Earth. Have a look at this.
High-resolution weather simulations, as provided by DKRZ's ICON code and vast amounts of observational data, allows us to determine the state of the Earth with unprecedented fidelity. But exploring and working with this data can be a challenge. Technologies like the Nvidia Omniverse peer review connector allow scientists to interactively analyze weather and climate data in 3D, to combine information from multiple sources, and to explore what-if scenarios. This takes us ever closer to a realistic, interactive digital twin of the Earth. Let's look at two examples. In August 2019, Hurricane Dorian developed into a massive Category 5 hurricane, causing over $5 billion in damage in the Bahamas and the southeastern US, with sustained winds of 185 miles per hour. Viewing high-resolution simulations like these integrated forecasting system simulations in Omniverse allows scientists to analyze the behavior of storms such as this in detail, interactively, and in full 3D. This not only aids in understanding the physics of weather systems, but also allows inaccuracies in models to be identified and refined. With the Omniverse ParaView connector, visualization modalities of ParaView, like streamlines, become available within Omniverse and can leverage the RTX renderer or be fused with data from other sources. These sources can be static or computed on demand, such as mapping service, surrogate model, or an AI-informed physical model. Here we show AI-based image segmentation of satellite data, which was used to detect flooded areas and to classify land use before and after Dorian hit. The network performing the segmentation can run as a service and be triggered on demand. Once we have interactive access to all this Earth science data, a next step is to play through different scenarios. On-demand evaluation of surrogate models or access to real-time physics engines can help explore the impact of our actions in this virtual world. With access to real-time physics models as enabled by Omniverse, we can not only explore pre-computed data, but also simulate on the fly. Here, we use real-time fluid dynamics simulation to show the vapor plume emerging from a cooling tower. A user can quickly explore the impact of the plume, depending on the wind conditions or the steam output. Similar models can be used to interactively explore the dispersion of aerosols or contaminants. Nvidia Omniverse is a powerful platform for massive-scale digital twin simulation. We're excited to see where it takes us next.
So essentially, as I was telling, these three powerful revolutions are happening in front of us, and we need to be ready for supporting the underlying requirement of infrastructure for that, and accelerated computing is path forward. Before I leave you, I wanted to invite you for our technology conference. Nvidia GTC is our technology conference, which we do now in a two times in a year cadence. This is a technology conference unlike anything else. We have shifted this into a fully online conference given the pandemic situation. The last conference, the keynote, which is typically done by our founder, has around 14 million plus viewers, and he lays out our entire technology roadmap for the year and the developments which we are seeing in the industry in this conference. And then we invite our users and customers and partners to talk about what they have done and the amazing work which they've done with the technology. This time, this is in November 8th to 11th. Last GTC had around 1,600 plus sessions. It had participation from across board industry leaders and topics covering from AI to 5G to everything in between and robotics and AI. We have the most brilliant minds in the world speaking at the conference. All the 3 Turing Award winners were at the conference, 12 plus Gordon Bell Award winners, all the 12 plus Grandmasters of Kaggle. We had even 12 Oscar Award winners at the conference. This time, November 8 to 11, registration is completely free. We're targeting around 500 plus sessions and the most brilliant minds in the world to participate with us. Please register. My colleague will be sharing you in the chat box the link for registration, and I look forward to seeing you at GTC. I hope this was useful. Thank you.
Thank you, Nick. Seeing you after a long time.
Yeah, Agendra, same here.
Right. So I think we've got some good learning from various sessions, including the last one by Unni from Nvidia. I'd just like to mention and acknowledge the presence of some of the senior officers from government. We have with us Mr. Anand Kumaran. He's the Managing Director of MAP IT, Madhya Pradesh Agency for Promotion of Information Technology. We have Mr. Arunachalam, who's the Director at New Space India Limited. And we have Mr. Anisur Rahman from Indian Railways, and also Dr. Sandeep Goyal from MAP IT, and many other senior officers from government. If I have missed some names, please pardon me for that. Let's continue with the next speaker. And I think we've got a lot of good learning, and I will come back a little later to conclude. Megha, over to you for now.
Thank you so much, Agendra. And thank you, Mr. Uni, for your very interesting presentation. There were a couple of points in the presentation where I was actually going, wow. The technology that Nvidia offers is really, truly awesome and very futuristic. If you don't mind, I'd like to ask one question.
Yeah, sure. Go ahead, Megha. I'm sorry I cut off my video. I thought
Okay.
we had run out of time.
Okay, no. Just a very, very quick question about the geospatial industry. So as we see that the geospatial applications demand is going to now rapidly increase, how can a geospatial organization quickly build IT infrastructure to match the pace of development?
Yeah, actually, thank you, Megha. This is a question very close to my heart, right? Along with Agendra, Department of Space, and the entire geospatial as being our core playing ground and learning ground. I think the opportunity is unprecedented, right, with AI for us, particularly for India. And the reason I say that is because the core ingredient is data, right? And in India, the data is so vast, which we have. It is not just vast, the diversity of that data is also unbelievable. And as far as geospatial per se is concerned, I know it's even more better because we have everything to take us to the next level with whatever the work Department of Space has done. Across both the entire spectrum of operations of Department of Space and the geospatial industry from there, you have capacity to get transformed by AI. Underlying infrastructure which you need for this needs to be taking cognizance of the components which I discussed. But to get quickly into it, any organization, what I think needs to do is to define get top to bottom buy-in for this, particularly from the top management. They need to then get to understand what is the most critical use cases which is of priority for them. Identify how do they get that done first, define resources for it, look at the data that they have, identify the way they are doing it, the way they are organizing it, where they are readying it, and is that needs any transformation to support this use cases enablement with the new AI process which you have, and then build your team and go ahead and execute. And then the core fundamentals of planning, process, people, etc. come into play. Whatever you asked is honestly $1 million question, big consultancy project, but I think the core fundamentals is this.
Great. Thank you so much for your inputs, Mr. Uni. And with this, we would like to move on to our last speaker for the day, last but not the least, Mr. Sanjeev Chauhan, Senior Director from Oracle. Sanjeev is a Senior Director and Field CTO for Oracle's technology business. He is a technologist with extensive experience in enterprise architecture, software development, open source, infrastructure, data center design. Sanjeev has worked with IT majors like Tata Infotech, Pentasoft, and Red Hat before joining Oracle in 2008. In his current role as Head Technology Business Solution Engineering and Chief Technology Officer, Sanjeev and his team help customers with architecture best practices and support them during complete life cycle of technology adoption. So with this, over to you, Sanjeev.
Thanks, Megha. And I hope my slide is visible now.
Your voice is very faint. Can you...
Yeah, Megha, is it audible now?
Your voice is very faint. We're not able to hear you very clearly. Yeah,
Am I audible now?
Yeah, much better.
All right, sure. I think it is to do with the headphones. Hope my screen is visible now.
Yes, we can see your screen.
Okay, sure. Thanks, Megha. And good afternoon, folks. My name is Sanjeev. I am Field CTO and Senior Director for Solution Engineering at Oracle. Further to what Agendra said, that there's a huge untapped potential with use cases for geospatial data. There are numerous use cases that we can think, at least in the government entity space. You can analyze, this for national or local data sets, for digital battlefield, surveillance, contact tracing, crime mapping, predictive policing, emergency services. And you, let's say, take these use cases to smart cities, where countries and cities are mapping the large and complex land spaces for registry, mapping agriculture use cases, 3D city modelings. For engineering and construction companies are combining this GIS and CAD systems for building information modeling, facilities management, connecting workflows, eliminating data silos, right? So there's huge potential that we see here. Oracle's spatial and graph data is inherent to Oracle. We launched graph and spatial data option in Oracle way back in 1995 with the Oracle database version 8. We are currently sitting at version 21C. So it's a long association with industry and how, let's say, we've seen the data evolve over a period of time. Oracle Spatial and Graph is the most comprehensive and widely used spatial database in the world. It includes advanced graph database and analytics capabilities to support variety of use cases, social network, linked data, relationship and pattern-based analysis. And though we are seeing this new interest in the industry, but with Oracle, we have seen that lots of our customers for almost a decade in India have been using these capabilities very, very strongly. In addition to what I'm going to speak about, so this is what, let's say, we do at Oracle. So we do everything that, let's say, any customer in spatial would require. And you marry to these the current buzzwords, I would say, let's say, the industry expectation, which is cloud native, which is digital first, which is essentially ensuring artificial intelligence and machine learning. So what we've done is that we do have a machine learning and artificial intelligence as a service that we offer both on-prem to the customer and as well on the public data center. But what we have ensured is we've taken that intelligence and has pushed that intelligence at each and every product level. So look at, let's say, the underlying storage and server and virtual machines and operating system, right? So clearly, these auto upgrades, the machine takes care of its performance automatically. It automatically eliminates the bottleneck areas, does the mitigation as much as possible, right? And does all sort of alerting and other mechanisms to ensure that the people know well in advance there's something wrong that is happening with the underlying hardware. In case of database, most of the time the database administrators spend their time in tuning, performance monitoring, rectifying flaws in the system, upgrading, patching, etc. So today with autonomous database, both on cloud as well as on-prem, we take care of all that administrative task by, all of that is taken care by the algorithm, right? So algorithm takes care of creating indexes and then compare the performance with existing indexes. And if, let's say, the new performance is better than the existing indexes, drop the older indexes. So all that work is automatically taken care. And a huge stack of applications, whether it is industry related to hospitality, where starting from front-end POS to a back-end application, or for that matter, let's say a core banking application or a core billing application, the complete stack comes from Oracle. So we do everything starting from underlying disk subsystems all the way till the applications, and they're all available in different models to you. You can get them on-prem. So a lot of our customers are running them on-prem. They can run it as offering on the public cloud, or they can bring the whole of the cloud offering into their data center for every single stack that you see here. Now moving on to, let's say, the multi-model database, the conversation that we thought we'll spend time today, because many of you are decision makers, developers who are looking at, let's say, building applications and seeing how can we help you, support you, helps you speed up your development process. Many of things that you would actually build yourself, how those things can be automatically be given as an API to you, right? So you don't have to spend so much time building the infrastructure and the data structure from scratch, right? So clearly the idea of having specified data models that address the needs of specific classes of application has existed for a long time. Folks have had, let's say, XML-based databases, 20 years ago. JSON-based database is quite new. You see unstructured and structured databases. So there's quite a proliferation that has happened for a variety of individual data types. But the expectation in the industry today, because you work on those niche databases, and over a period of time, once you want to scale, they are not able to at times achieve the kind of performance that you're looking at, right? So clearly there is expectation that you should have a multi-model database which can do specific things for you, right? For that matter, let's say if you're looking at GeoJSON, which is the format that in which you store your geospatial data, that should be native inside the database rather than you having to, let's say, store it as a lob inside the database and you can't do any amount of analytics on the that particular data, right? So all of these should be native capability available inside the database. And over the last 2.5 decades, we've done significant amount of work to ensure all of this is native to the database. So we have one of the best multi-model database available in the market, and for spatial data, it supports spatial, graph, XML, JSON, and OLAP data models. And truly, let's say the data model that let's say is giving a lot of facilities to the end developers out of box. So if you look at this, the common thread connecting spatial and graph analysis is that they enable applications to better understand relationship rather than simple aggregations and sums, right? You can analyze common spatial relationship to questions like, what is the distance between two different assets, right? Are people in the same region, right? So you have two coordinates and you want to, let's say, calculate the distance. You create a polygon and want to figure out whether those people are in the same region, right? Can I guarantee delivery in a fixed amount of time, right? So when you use, let's say, mapping application, you would want to, let's say, map the distance on a plotted area and see based on the current traffic flow and based on the historical data, can I guarantee that I would be reaching there in a certain amount of time, right? So all these are, the business logic or the asset that you build yourself, or you can very well just use an API, right? I remember many of you who are developers in today's conference. If you were a developer way back in 2000 to 2003, databases did not have basic things like a primary key, right? Where you would have to create a table and generate your own primary keys, right? The databases, you couldn't drop tables, you couldn't drop columns, right? All that is given today, right? So something similar in the spatial space. So all the most of, let's say, the XML or JSON-based databases are just data store who can store a file in the JSON format. They don't understand the spatial and the graph format, right? Where in case of Oracle, we do that quite natively as far as the database is concerned. Then there are, if you look at, let's say, spatial and graphs, and if you look at what is that a developer can use today. So spatial and graph has three major things that you require, right? A spatial database which supports all kinds of geometries and geographic data, right? You can do thousands of analyses and functions and operators. As I mentioned, a primary key is the most basic of things that you expect inside the database. That was not the case 20 years ago. So exactly the case in many other NoSQL and JSON database types today. You expect very basic functionality, wherein, let's say, we have evolved the whole developer portfolio to such an extent that many of things that you do, and which we'll discuss during the rest of the presentation, all of that is natively out of box available to you. So you can get started very, very quickly. The second thing that you require is a property graph database, an analytics algorithm for social networking, discovery-based systems. And the third thing, which is quite native to, let's say, any developer who's building application, is a W3C standard, RDF model database for linked data, knowledge management applications. And all these three should be highly scalable, great performance, and security should be native to all of these, let's say, data types. So at least you ensure that whatever you've stored inside the database, that is secure and can't be accessed by, let's say, even, folks who are currently super user managing this data. And it should be seamlessly integrated with other database features, right? For example, a function like search, a function like, finding distance between two different locations. So all the functionalities that you do today in relational databases, all those functionalities should be available. One common language that which, most of the database administrators are quite familiar with, it's called SQL, Structured Query Language. So ensuring that you can use your existing knowledge base or a Python, which is existing knowledge base, and can query the database based on, let's say, what you know. So Oracle Spatial, what you can do today, where you can deploy with Oracle, and we get into little more details in terms of features, what is that you get as a developer out of box today. You can deploy it in your data center. We have 2 cloud data centers in India, 2 regions, one in Mumbai, one other in Hyderabad. So you can very well deploy your applications in these 2 data centers. As I mentioned earlier, we have artificial intelligence at every tier of architecture, which is what I'm sure, let's say, you would have heard earlier is autonomous database. So every single function that which is done by administrator, right? Starting from a security patch to creating indexes, performance management, monitoring, any sort of rectification. All of this is today automated today in the offerings that we have around transactions and data warehousing. So you can very well run your spatial analytics on that machine. So which essentially meant that you don't have to carry database administrative skills to develop applications, store your data. And if let's say you want all of this functionality in your data center, so you can take all the benefits of cloud, which is your operational cost, whether it is your management and monitoring, somebody else taking care of SLA for you, and you can run it in your data center. There are other capabilities of Oracle Spatial and Graph in Oracle database, which are here at a glance for you. Looking at this, it can be quite overwhelming in terms of the set of features that it offers, right? But that shows how comprehensive the product portfolio is, where you can just store directly your geometries inside the database rather than storing it as CLOB. You can just store a geometry inside the database, whether it is line graph or polygon. The graph capabilities that includes here are the models, algorithms. You have query languages, support for tons of different query languages that you use as a developer. APIs for both property graphs and your RDF knowledge graphs. It also has support for all classes of spatial data for applications that use, whether it is interior, exterior locations, sensor information, satellite, aerial informations, and the land management data. And here is an example that how do you store actually the geometries inside the database rather than storing them as a CLOB, which you can't query directly because it is just a large object for you, which is there just for a storage purpose. So your basic in database processing consists of native geometry data types, specialized spatial indexing, hundreds of spatial operators and functions, which essentially meant that you don't have to define yourself. All of this is done with, let's say, 2 decades of development experience, right? And some of the examples, what is available, I'll show you. Otherwise, hundreds of these functions are already built, which you can just start leveraging and start building your applications starting from day one. In terms of the spatial analysis, at its core, the spatial features includes, as I mentioned, hundreds of functions, right? Which is related to filters, combine, transform, measure on the geospatial data. There are APIs which are based on these geographic elements. For example, you can find customers in a sales territory using a certain query. You can aggregate all office cubes into a floor space, right? Which is typical of, let's say, a SQL query running on a geospatial data. Otherwise, you'll have to, let's say, literally do it in a UI format, or you to literally write tons of code to do exactly the same. But now the aggregate function that we run on numbers, you can run the aggregate functions on geometries, right? You can also find the center of a postal code region or put a security zone around a park, right? It is literally like, you're geofencing a certain area where anybody that who enters a particular zone or leaves a particular zone, immediately he or she is notified, right? And of course, you can perform distance queries, such as finding closest store locations or customers within a certain distance. So these are the features that you usually see inside, let's say, professional mapping software that you today use for when you're traveling from location A to location B. But there's tons of code, tons of, let's say, APIs that those companies have built, and all that API is available literally free of cost to you, right? So if you're using database, it is absolutely available free of cost to you. There's no additional charge for using these APIs, right? Which is obviously this hundreds of functions built by Oracle, right? And you can very well run this on any earth coordinates, which is geographic in nature, or any internal floor plans, which is absolutely non-terrestrial data. To perform connectivity queries in real world for transportation, utilities, and energy application, the spatial and graph has the network data model, right, which is all available to you. For land management and cadastral map, which is a comprehensive land recording of the real estate or real property meter and bound of a country. In most countries, legal systems have developed around the original administrative systems and use the cadastry to define and the dimensions and locations of land parcels described in the legal documentation. So it includes topology model to ensure accuracy and consistency. So that support is natively available inside the spatial and graph, that you see, which is available inside the database. Other advanced spatial features include support for remote sensing, satellite and aerial images, through support for raster data, as well as other 3D and sensor data like point cloud and LiDAR. For point cloud, hundreds of millions or even billions of points are captured by sensors using, let's say, LiDAR. Each point has XYZ coordinates, and a number of parameters, which is color, timestamp, return number, etc. You use specialized tools, to extract the structure from the point cloud. For example, building outlines or shape of the seabed. And for solids, mostly for building outlines in urban landscapes, each building is represented as a set of connected faces. Typically, a building will be stored in multiple copies with different levels of details. Building faces are associated with textures, that is, images that make them look more realistic when you actually visualize them or simulate them using a simulation tool. Then you have something what we call is triangular irregular networks, which is TINS. It represents object using a large number of triangular faces. They are often extracted from the point cloud. You build the data using the point cloud, and then you extract it and build the triangular, irregular networks. Then your 3D coordinated systems. The database has a full understanding of the 2D model, which is the XY coordinate and the XYZ coordinate for a 3D model, and can perform conversion between the different systems. So you can do the conversions between these two different systems. This is important, for example, to relate a 3D GPS point, which is Langlot and Langlate and elevation with surrounding 3D structures. You can superimpose the structure on a particular elevation. 3D queries combine spatial and non-spatial attributes. So you can combine a spatial attribute that you've captured is a raster, and you can combine it with any other, let's say, relational data. Example that I can think of is that you want to find all the buildings, which is where a point is visible from all those places, right? So all of that, analysis you can do using just mathematical calculations, and you don't require a specialized tool for this purpose. The other things that you can do is, and which is available, let's say as a feature, is what we call the Spatial Studio, right? So it is inbuilt free tool available to all the users, where it's a self-service low-code web application, because the expectation from, let's say, usually building this kind of complexity is that you need folks that who understand GIS and some of those, let's say, MapGIS and some of those front-end tools who can enrich the data. But you definitely need, let's say, some sort of programming skill. So the expectation is that you then get another set of skill who would not understand, geospatial information, but would be good at programming, right? So what we did is we married these two and thought, let's say, why don't we bring this, the business user developer thought process from, let's say, the other industries where there are lots of the self-service application, let's say the HR users or banking users are building for their own departmental application. So can we bring that, let's say, use case here, right? And we brought the same thought process here. And today, a business user can literally, drag and drop somebody that has understanding of geospatial data, can build those applications themselves, right? So it's a Spatial Studio, which is absolutely zero code. In case you want to write certain functions, you can, but all the functionality is already inbuilt, right? So it simplifies the use of rich spatial analysis and query capabilities in Oracle database. With Spatial Studio, you can easily create, publish interactive maps to display the results of these queries and analysis. You can use Spatial Studio with on-premise, you can use it on-premise, as I mentioned earlier. You can use it on public cloud, or you can do the hybrid of these where you can bring it in your data center. There are other things which is around a function that we brought from the relational database, which is around the sharding. So sharding is a concept where you take certain data and shard it across, let's say, various, simple shards, and then put those shards geographically at different locations. So for example, let's say if you're looking at, the data residency issue where, you require data locally here in the country, or you're looking at, let's say, data sharding for the reason of performance, because all this data in a single instance, it is difficult to process, right? So is there a way that I can, process it by creating smaller entities, but whenever I need all this entity together, I can query all the shards, right? So that is what we call sharding. So we had this concept where we were doing this as part of the relational databases, and today we run this as part of spatial databases where we can do the complete sharding at a single environment, right? The other benefit that we see, and other features that which are part of spatial and graph, is called the faster network analysis. So we have network data model now supports contraction hierarchies, a high performance cache for network analysis. Contraction hierarchy is a pre-computed in-memory approach that can significantly speed up the path computation. It's like you pre-process the data and keep it inside the memory. So it's again a concept that comes from the other industries, which is where, let's say, the huge amount of transactions, make a difference in terms of, let's say, overall performance of the system. So we do that for a variety of use cases in banking and telecom. And we have this feature inside the database called in memory. So where we pre-process some use cases and keep it inside the memory. So whenever, let's say, the user comes, so he has these pre-processed results already available to him, rather than he having to have compute them in real time, right? So some of these functionalities is already there as part of the system. There are a few other things like location tracking server, right? So this is where today we see that we have a set of polygons, and you can very well geofence a particular location. So this is done using Oracle Geospatial tools, where you can create a polygon, set certain condition, get the data in real time, and you do action on the real time data. So, for example, if you geo-tagged or geo-fence certain location, if an object enters a certain area and leaves a certain area, so there are certain events generated, right? So the complete end-to-end event processing, map management, data management, all that is taken care by the application itself, right? There's another use case which we did for a couple of European customers and large customers in the US, is where is, let's say, COVID track and trace, right? Where you want to do, let's say, proximity analysis, and I'm sure all of us are familiar with the Arogya Setu app, where you switch on the Bluetooth and your network connection, and it'll do the proximity analysis, right? But all of this is essentially, then you have to, let's say, write a lot of code and ensure that that code actually works for you. And frankly, that same geo tracking or contact base can be actually used for a lot of other use cases, which is the known criminal were at the same place at the same time, whether ships at sea stopped close to each other for something, right? Or tracking wildlife migrations or social matches, right? So all of this can be the use cases that you can very well use, and these are some of the use cases that we are working with our customers on. And earlier, it would be, let's say, huge amount of, let's say, work for you to build that application yourself. Today, it's just a simple API inside the database. So you can use a network monitoring API inside the database, provide the data, provide the endpoints where these data is generated by these individual IoT devices or, let's say, mobile handheld devices, right? And all of this can be processed in real time, for end customer. There's another use case, for example, let's say if you are not in external environment and you don't have the GPS data, then you can very well with this, right, where you can map the whole building in your database, and then you have the swipe in and swipe out places, and you can map the entry and exit points, and then you can very well do the analysis of what was the proximity or probable proximity of, let's say, these individuals right next to each other, right? So these are all the APIs which are available out of box now, so you don't have to really write a lot of code and do anything about it, right? The another thing is about spatial visualization. As I mentioned earlier, the visualization tool is bundled. It is available inbuilt free to all the developers, right? So in case, let's say, you're looking at building an application, you can start using it today. The other few areas is around the property graph and the RDF graph, right? So first of all, the property graph allows you to do many things, right? So extract implicit information about your data using graph analysis. You can discover graph patterns in big data, such as communities and influencers. You can generate recommendations based on interest profiles and past behaviors, right? So all of that is available out of box. These analyses are available out of box for you, right? And what is unique about Oracle's property graph is that in addition to having a graph model in Oracle database, when you can perform graph queries, we also have in-memory analysis engine where you can run these graph algorithms, as pre-process the data for you, right? The in-memory analysis engine is property graph, PGX, provide many built-in algorithms, which is out of box available to you. These are some of them that I mentioned here, right? Moving on, so the RDF graph, there are a broad set of standards and features that are expected of the RDF offering, but some key features that you can think of is native SparkQL query language support available, right? There's absolutely endpoint support available. SQL support is available out of box, right? So if you're a SQL user, it should be fairly straightforward and easy for you to use the database. We have tested it for for a customer for 8 petabyte of benchmark, right? So a single system with 50 billion trickles and up to 8 petabyte in data. So and security is quite native to Oracle. We understand security very well because we've been running the financial systems for all 100+ banks in the country. 100% of the banks in the country runs on Oracle. 100% of billing and telecom systems run on Oracle. 100% of insurance companies run on Oracle database. So we understand that security is very, very critical to all our customers, and hence do that security as grounds up, which is inbuilt inside the database itself, right? Now moving on, and this is a summary slide for me, is Oracle Spatial and Graph enables you to treat spatial data and perform spatial and graph analysis in the same way as other business using the same IT infrastructure, right? So this, do we understand it is a spatial data? The coordinates are different, the way you store, the kind of analysis that you use slightly different versus the relation data. But we have brought the same concept just to ensure that the scale and performance improves, and we can use the existing tools to extract performance. And hence, the support that we have provided for this inside the database for last 20 plus years, right? So it helps make use of the IT and management capabilities of database and middleware and minimize strategic risk of investing in new technology, right? It enables interoperating through open standard systems, right? Many of these things are open source and we follow 100% open standards. So none of this is a very, very proprietary standard that we built for ourselves. We just follow whatever is the industry standard that we have seen in the market. We also allow developers to concentrate on business requirement rather than infrastructure. As I heard, in the beginning from Megha, that most of the time is spent, and all of you understand your business and you understand geospatial data, but the maximum amount of time is spent in building that infrastructure for you, right? And many of those things are out of box available to you, but as far as database and as far as some of this functionality, you'll have to build them from scratch and do that grounds up work, right? But we are here to ensure that all of this is integrated, consistent system is available to you out of box with hundreds of functionality already pre-written, and this is a very mature infrastructure that you can start using immediately. With that, thanks, Megha.
Thank you, Sanjeev. So we have a question from Parthiban from Honeywell, who's asking how is Oracle different than SQL in geospatial implementation perspective?
Yeah. So when I'm hearing SQL, so I'm assuming it is SQL Server or MySQL, right? And not just Ngc SQL, because when we say SQL, it is interpreted differently, right? So one is that there are set of standards that everybody follows. I'm sure, let's say Microsoft, or whenever he mentions SQL, whether it is MySQL or SQL Server, they do follow the similar set of standards, let's say, as all of us do. Then comes is, let's say, enhancements that you have inside the system. So if you look at, let's say today, Oracle database does, we are #1 database, right? So we do lots of things which is pre-built inside the database, right? So for that, you don't have to write a code yourself. So we thought of every possible customer scenario. And we said, okay, the customer would need this. So can I build it as a functionality and keep it inside the database so somebody can just come and start using it? So these hundreds of functions that I mentioned that which are there, these are not there in any of these two other databases that are there, which is, track, trace. And these are the APIs that we build over a period of time, right? So this is the functionality which is available out of box. Developer can start using it. And the example I gave 2 decades ago when we were programmers, so the primary key itself was not available. So primary key is the function, is the unique key that you use to identify anything unique in the table, right? So, for example, a bank account, or for that matter, let's say Aadhaar ID. And that was, not available, let's say 2 decades ago. So we end up writing our own primary key at that point in time. So think of, let's say, geospatial, end customer today, who would have to, let's say, define all that from scratch today, right? In an additional database which just provides some rows and columns. And we have these, hundreds of functions and APIs available in addition to, let's say, taking care of every kind of data type, inside the database. In addition to that, some of the other add-ons that we have done to the database is called around autonomous, which is not there inside any database today available in the market, which meant all the redundant task or anything that is required to the underlying infrastructure is taken away and is done by the algorithm, whether it is a backup, whether it is performance tuning, whether it is security patching, whether it is encryption. All of this is done by the algorithm. So for a special user, he doesn't have to be, let's say, a database administrator. All of this is, just he has to point to a particular database endpoint and say, here is my database, and everything else is taken care by the underlying database for himself, right? So these are some things that I can think of. I have, you have my email address. So if there's anything specific, let's say, that is there as a query, we can continue the conversation with the gentleman later.
Wonderful. Thank you so much, Sanjeev, for your participation. And now that we've run out of time, so I would like to invite Mr. Agendra Kumar back to give his concluding remarks.
Hi, Megha. Thank you, and thank you, Sanjeev, for very insightful presentation. I also want to thank all the participants for being with us today. A lot of good learnings from these sessions. As we know, geospatial data sets, the processing requirements are changing very rapidly because the availability of data is becoming easier and much larger. So new data sets are going to be available, and already we have seen so much of data generation. And some of the technologies we discussed today, like integration of data coming from various IoT devices, and also use of a number of AI and ML based applications for feature extraction or finding out patterns from the tons and tons of data which comes in, and using that for identifying the trends and making some decisions. And we have seen that in many situations where this data is being processed in an automatic manner. Whether we use cloud computing or edge computing, these technologies are all available, and based on what is the requirement, one can choose the appropriate technology and what is available and most appropriate for that particular requirements. The good thing which I believe is for today's discussion is that we had different angles of thought, different ways of looking at the same challenge of managing geospatial data and running these applications successfully. I would say that if we look at nutshell all the presentations which happened, whether it was Rangan from HP or Abhijit from Dell or Sanjay Jha from AWS or Unni from Nvidia or Sanjeev Chauhan from Oracle, they gave perspective. They shared their perspectives about how they and their companies look for managing different data and applications and infrastructure and what they recommend. So from a cloud-based approach to a on-premise based approach to a hybrid approach, we saw the benefits of each of them giving different circumstances. So I think that was the value which was expected, and we've got a lot of information, a lot of knowledge, a lot of examples, a lot of new things which we can use in our thinking and planning our infrastructure for managing the geospatial data and applications and building geospatial infrastructure for using what we do in our areas. Another important thing was that a lot of good insight. I mean, we probably were not updated about so many changes which have happened in technology, and each one of them had a lot of new things to share. At least for me, there were many things which I did not know prior to going through these sessions. So that's another good learning, because technology field is evolving very rapidly. A lot of new changes keep happening, and some of these concepts are very, very new, and they're very valuable for geospatial industry as well. So with that, I would like to wrap up by saying thank you to all our speakers for taking out their valuable time and presenting, and all the participants also, because without your active support and participation, such an event will not be successful and not have the value which we expect for a session like this to provide. So thank you everyone, and thank you Megha and the rest of the members of AGI Secretariat for organizing this event, putting together a good content, a good thought of getting the relevant perspectives from different industry leaders for the benefit of all of us. So with that, I'd just like to say thank you, and see you again in our next session.
Thank you, Agendra. And before we close, yes, we would be happy to share contacts of our speakers in case you have any further questions you would like to connect with them. We'd be happy to do that. You can reach out to me or any of my teammates. With this, thank you, and see you next time.
Thank you.